Good day, everyone. I hope you're all well, and thanks again for attending the second day of Crossing Conference. Those of you who were participating yesterday have seen a number of talks to different topics. And as I mentioned in my introduction, Crossing Conference is about bringing together experts and top scientists from industry, from academia, but also from government organizations to talk to each other. Usually we have this conference, which is a very exciting conference. I can guarantee you, if in 2 years, or let's say next year, we have a kind of extra additional conference like this, so that we can invite those of you who were not able to come to us, because currently it is mostly virtual conferences. You will see that you will enjoy the conference, talking to so many experts, learning new things, and being inspired. That is the reason why we organize this high-profile conference every 2 years within the German Science Foundation Collaborative Research Project Crossing. And as the Crossing says, it is a crossing of different disciplines. We also consider, because its Crossing project goes over several years, 12 years until now, we would like to have also long-term vision of security and privacy research. So just to wrap up what happened yesterday, and then I will go shortly to what is going to be done today. So yesterday, we started with demystifying quantum technologies, because this is part of the Crossing collaborative project anyway, but quantum technologies have been for a long time hype and a very hot topic of research, and they are going on. And I think in future, we will see huge developments in this direction. Billions of dollars are being invested specifically in China. And we are going to have surprises in this area when I talk to experts in this area who are not only, so to say, enthusiastic about these technologies, but also are realistic. They have realistic view to what would happen in the future. Think about it, it took a long time until we are getting addicted to our smartphones. Then we also talked about different other aspects, like secure computation, how we bring cryptography with secure hardware together. And we also had talks on emerging technologies by Leila Batina, Nelly Mentens, and Stefan Picek, showing different directions from bringing electric circuits and security functions and primitives to the plastic, very thin plastic, which is, there are several papers in Nature about this, which is a very exciting research direction, to how to use machine learning algorithm and automatism to extract information, the leakage, to analyze the leaked information from systems, to kind of extract the secrets. So that means emerging technologies like machine learning, like AI technology in general, are coming into the focus of not only current research and in commercial area, which is the big source of money and the source of investment, but also in research, we have a number of problems that are not solved, and specifically the insecurity of machine learning algorithms and many ways of manipulating data, and consequently manipulating the outcome of these algorithms is something that is of interest to us. And this is why a number of talks were focused on this topic, like, for example, the talk by Salman about secure aggregation in the context of federated learning, which is also very important for practice. We also had a interesting talk about new results on deniable encryption, because cryptography is a core technology, is a small part of the security and privacy, but is an important part. And we had the honor to get a talk from Shafi Goldwasser, the Turing Award winner, who has really influenced theoretical computational theory, but also cryptography. Another aspects that we looked into it were from social point of view. What are the impact of technology on our society? Because we are now in an era that social networks completely, so to say, influence and impact even our politicians, and they guide them through wrong and right. And we also have a pandemic, and during this pandemic, not only many people suffered from it, students suffer from it, but also people who are doing really essential jobs, and many people were forced to use digital technologies. And our governments had some absurd ideas to use digital technology to break the infection chains with the wrong ideas of doing wrong things. And there are critical researchers like Joel Redron or Serge Baudelaire who work in this area to bring awareness to society, but also to politicians, as long as they are not pretending to be theft. Now, today, we are going to have a number of other aspects that we're looking into. So in the morning, we are going to have a talk on values in programs and systems. I will come to that very shortly. Then we will have a talk which is more on the physics part, because it's a considerable portion of our crossing project, bringing physics, engineering, and computer science together. And as I said, quantum technology will play an important role in future. At least this is true in my view. Then we have very interesting talks about, about threat analysis, about security and reliance, and how AI can help there, and how AI can be a pain there. And to make these things also more clear with regard to technology transfer, we have in the afternoon a discussion with Ammar Alkassar, who is a CIO and State Commissioner for Strategy and Innovation, and he is someone who knows what he is talking about, because I know his background. I will come to that when I introduce him. And with some very promising startups in Germany, not only in Darmstadt, in Germany. We invited some of them. We cannot invite all of them because of time constraints, but have a discussion about what is the cybersecurity as a key technology, but also how we can make a startup with it to build an environment for transferring the results of the university and academic research into practice as we all wish. So, and at the end, we also have a very interesting talk. I can recommend you to come to this talk. It's about privacy-aware data mining for online advertising. We invited Vahab Mirokni, who is leading the algorithm and theory part in Google. And this particular direction of research, which is not really new, but it is now getting lots of attention, is specifically related to what Apple did recently with giving the user the chance to say, I don't want any advertiser to have access to anything that I do. Let's say, theoretically, this is what Apple tried to do, and it generated some conflicts with Facebook, because they are claiming in that case many startups and many small companies will be ruined. And indeed, privacy-aware data mining will be a topic again, specifically because we have also the option of applying sophisticated AI algorithms. Then we have also a keynote on collaborative learning by Srini Devades from MIT, who is very active in this area, and he's also leading an institute at MIT on machine learning and security. So, and for those who are interested in DARPA projects, and that means many of my US colleagues, Keith is going to give a talk about hardware security, because he's a program manager responsible for hardware as the fundament, as the foundation of any computing system. And I hope that you're going to enjoy that. And last but not least, Jason Fang, he is the head of defense technologies and security defense in Intel Corporation. He is going to give a talk on scalable hardware security assurance that relates to the talk of Keith. So with that, I would like to go to our start our first speaker for today. That is Liang Zhenkai. I know, of course, Zhenkai for a long time, because as you may know, Singapore is a small country, but it's a very fine country. And specifically, this country is very strong in security research, for those of you who don't know. And one of the pillars of security research in Singapore is Zhenkai, who is from National University of Singapore. He is extremely active with his, let's say, vast number of contributions to our international security community, but also privacy aspects. And he's going to talk about the research for meanings and values in programs and systems. It is a philosophical title. I don't know how much philosophy is in it, Zhenkai, but in general, I'm really happy that you accepted our invitation. I know you are also a busy man. You are a member of many bodies and steering committees, and extremely active in our community. But you know that nobody says no to me, but thanks a lot for being here, and the stage is yours.
Thanks, everyone. Thanks, Ahmad, for the invitation. Unfortunately, we missed the trip to Germany, although currently Singapore and Germany border is open. We are looking forward to visit in the future. And today, my main topic is to summarize a few research activity we did in the area of system and system security, program analysis, and the APT response. We look through a lot of observations, and from there, we want to get a high-level understanding and meanings. That's why I call the search for meanings and values, or search meanings through values in systems. And my topic is motivated by a lot of attacks. We often see the instance, and from here and there, and we need to go for the investigation, and also we need to look at the vulnerabilities, look at the programs. Recently, there's a lot of attacks, right? Like Twitter and the Singapore health data attack, and also the big one is the SolarWinds. So the attack is there and is hidden for a long period, and when things are discovered, there's a tons of data to be analyzed. In this analysis, typically we need to say what happened and who is affected and how to prevent, and also we need to look at our own system to understand more about the system, about the binaries. That's the overall theme of this line of work. In my view, this is a challenging task because it's a game, right? It's a game with a lot of missing information. The elephant is a representation of the system and attacks. After attack has happened, the researcher's job is actually to inspect what is happening and try to understand what is going on. But to me, it's just like this process. A lot of people cover their eye and try to feel what is there and piece the information together. But every of us, right, every of the researchers just get a partial view of the whole problem. Right? Some feel the elephant by the ear, and some feel the elephant by the trunk. So, for example, one of the line of work we are doing is a binary analysis. We feel the elephant from the binary angle. So here, even from the binary, there are multiple views. We may grab some piece of code after the attack is happening, and from there, we can disassemble it. I see what recover the assembly, and sometimes we want to recover to the source code level and see what is going on. And also from the binary, we can get a control flow graph, and we get instruction trees through dynamic analysis. There are multiple ways to view the binaries. Also, for good programs, we can view the binary to discover vulnerabilities. Another important field is the audio logs, because we cannot afford to keep very fine detailed system traces or states. Typically, in the enterprise, they are keeping a lot of audio logs. So there are systems running on the system to generate a large amount of audio data. And if something happens, but they need to go to the audio log and to get a sense of what is happening. But as we see in the recent attacks, if the attacker is hidden there for months, right, or more than a year time, it's very difficult to go through the logs for such a long period. That's another challenge in our mind. Also, we can view the system from network level, from other levels, but eventually people want high-level understanding of what is going on, right? For example, if there's an attack from APT group, typically they are divided into phases, and after they get into get through the phases, through all the data we observe, we want to establish this level of understanding. Right? That's the challenge we are facing in security and APT analysis. So the most important challenge, right? The biggest challenge here is actually we made a lot of observation. We feel the elephant, but we want to make sense what is going on, right? What is the high-level behavior? What is the attacker's intention or strategy? That's not observable from all the low-level values. For example, in binary program analysis, we have one such function. The researchers' goal is to understand at this level. We want to know what are the binary, how is binary written, right, from the human point of view. This is the high-level, intended high-level meanings. But what we observe typically is this kind of objects, right? It's just a sequence of numbers. It represents a function, and there are solutions to extract the function boundaries I draw in the red. But even when we know the function boundary, we still don't know what is inside. Right? So that's the low-level values observed. To cover this big semantic gap, we need to do analysis or heuristic and whatever to fill in the space in between and recover the information we need until we can retrieve the high-level meaning. But as you can see, this process is actually a lossy process. Once you have an idea, design the software, and all the way you produce the binary or produce the system, a lot of information is either thrown away for the purpose of performance, or is commercial trade secret, right? They cannot be carried in the implementation. So that creates a biggest gap. In system events, the audit analysis, what is intended is actually this kind of high-level cyber kill chain and see at each stage what the attacker is doing. But what we can observe is typically this level of audio logs and a large number of them. So how to piece them together? There are many solutions, building a provenance graph, and from the graph to dependency analysis or statistics, eventually to make sense out of the stage. But in general, in this field, actually, we are doing a lot of searching, right? In searching for meanings in the values, but it's not soul searching. But I make the title fun to represent soul searching, but it's actually dirty digging to look at the values and connect them and try to make out the high-level meanings. One of our observation, if you think through these tasks, there are connections and the patterns in the observed behaviors. For example, in binary, we have the control flow graph, like the one on the right. And also we have the provenance graph from the system audit analysis. And now also there are different dependency and other representations, like the data flow and other dependencies. Typically, what we have been observed is through the past projects is these connections of these graphs, the context, right, and the ordering information. Actually, they carry some hidden information that is useful for the analyst, or some information is thrown away during the producing process is actually deeply embedded in those graphs. So that's why we want to set a line of research and how to uncover the meanings hidden in the observed values. Basically, we find the dependency, the relationship in the observations, and see how the observations can help us to reflect to the high-level meanings. So here we talk about two recent works. One is in the binary domain, the other is a recent one in the system analysis domain. The first one we call the Eclavia, is predicting the function signature from binaries. Eclavia is an Indian god who can sense information from phenomena. The task is as follows. Typically, when we do security analysis, we get a binary. We want to know what are the functions, what a function doing. If we don't know the details, can we know what is the signature of the function? That means what the function is, what's the input taking, and what are the types. The sequence of code I showed in the red before, here we can partition that into a list of instructions. And after you go through this assembler, you will know, definitely there are tools available, but this one is a concrete quantitative measurement of how difficult it is. It's by number of pages. Then you translate them into assembly instructions. From there, if you read assembly, probably you can make a guess. Right? For example, we need to first understand the calling conventions. Is using the x64 or vector call or other system 5 abstractions. For example, this one used the system 5 and RDI and RSI, RDX, RCX as a sequence is used to pass the number of arguments. If we know that, then we can say, okay, because there's two, the first two is used, then we can guess, okay, there are two arguments. And then we can, as a researcher, can further see how the instruction is used. If there is enough knowledge in compilers, people can make a good guess. The first one is the first parameter is later used memory access, probably is a pointer. And the second one is used in mathematical operation, it may be an integer. Right? That's a guess and experience. Based on that, probably we say, okay, that sounds like such a function. At least we know more about it. That's one important step needed in binary analysis to recover the function signature. So there are other follow-up jobs we can do. So in this work, we actually are inspired by NLP. Remember, the high-level view is what we want to infer some hidden information reflected by the connection or the patterns. So this particular work we inspired by NLP, since we say, okay, since we are dealing with the binary program, is like word by word. Right? Natural language is also word by word. There's recently a lot of progress in NLP to use the sequence of words to infer the meanings, the grammatical meanings inside the sentence, or even the meaning of the particular words. So in this approach, we use the neural network to augment signature recovery of a function from binaries. And also, instead of just saying that this AI magic, right, or deep learning magic, we are holding a cautious view. We want to check whether under what condition the technique work, right? Under what condition the technique doesn't work. So we have a model that we can check into and explain. And finally, we get interesting results from it. The whole setting is we are taking a binary of a function. We mask everything. We don't understand. We don't need to look into the assembly. The instruction information. We just need to know the instruction boundary, but we just ignore all the human knowledge about instruction. We don't need to disassemble. Then it's become a sequence of instructions identified by their bytecode. Right? We know it's an instruction, but we don't know what it is. And from there, it's like we are facing a foreign language, right? We know the words, but we don't know the meaning of the words. Then let's see from the NLP's experience, if there's enough information, enough program to be observed, actually we can infer meanings from the words and also infer the meanings from the sentences. Then we go through, we build a model and we want to recover the argument counts and the argument type information from a binary without understanding the instructions. The type we are talking about is like the instruct. That's the type we covered in this approach. In order to achieve that, we first make some embedding, right? Try to recognize the similarity of the instructions. We first make the one-hot encoding and then embed into a space. From NLP, we get inspiration. If the two words are similar, like boy to girl is equals to the relationship to queen, and that's established in NLP. And we want to embed, and we want to see whether the dots in the space we embed instruction can reflect the similar meanings. If two instructions map into the similar relationships, that's a good sign, right? So that's our intuition is so suppose their instruction, right? Push EDI and the pop EDI. Because remember, in this binaries, we don't have this disassembled information. We don't even know there are semantical meaning, but we know their relationship, right? They either always appear in a pair at the beginning of function or end of function, or they have a similar relationship with other instructions. Then we can infer there is a relationship if we map these two instructions into a point in the n-dimensional space. The distance between these two is a vector. So the distance between these two will be similar to push ESI, and the other one is a pop ESI, because they are, if our system works correctly, they should preserve they should infer this relationship. Similarly, the push EDI to push ESI, the vector will be parallel to the vector for pop EDI and pop ESI. That's the intuition, and actually in reality, we validated it worked. After we embed a model, that means through these patterns, right, the observation of the patterns, without going through the instruction manual, we know their relationship of the semantics. Right? That's a very good sign, right? So without going through a lot of manual details, we can recover a lot of relationships among the instructions. After we recover the relationship information, we send it to the prediction module. We train a model using the label data. That means we have a lot of open source code. We compile to binary where we have the ground truth and the label. Then we use that going through GNN to train it and to build a model. The model is the prediction module to decide, given the function, how many argument numbers it has and what are the types. And also another important thing we want to highlight is we are not necessarily trusting the results. That's why we need to build an approach to validate the correctness. Then we want to highlight the importance, right? If some input is changed, how it will affect the output. That's effectively is the gradient. For example, in the picture learning, right, picture recognition, so in order to recognize this dog versus the sand in the background, people can change the instruction pixels and see how it affects the results. If there is a great impact on the results, that means the particular pixel we are changing is important. So basically, it's a computer the gradient of many dimension of inputs and see how it affects the outputs. And we have very promising results. For example, this is one piece of function we train. Right? So it's a parse, step, struct, fuse in Planck compiled using Planck X6401. It has 5 arguments, and after we predict the function function signature, we can change the instructions one by one and see how they affect the output. Basically, see the gradients. Right? By doing that, we can measure the importance. If we change this move Q, there will be 100% of error. The result will completely change. That means this instruction is solely important for the decision of the function signature. And the other is because the R8 and R13 is used in the function signature in the calling convention, represent the fifth argument, right? R8. And the other one is the example is the BFD set system SymTab. And these two instructions are highlighted as very important to recognize the argument 1 as a pointer. Okay. So this one is actually consistent with human knowledge, and we have a set of validation, and the result is promising. After we have all this set up, we clean up a set of utilities from the standard Linux utilities, and here we actually recognize a very important thing. There are a lot of functions looks similar, and they're only different by some constant numbers. So that means we need to detect them and get them consolidated. Otherwise, we are effectively training the function we are training and detecting with very similar functions. The results can be biased. In the first round, actually, we had some, we didn't clean up. The result is surprisingly good, but later we found this problem, we validated. So I think that's a suggestion for this kind of task. We need to carefully validating the test samples. Otherwise, the results can be artificially inflated. So based on the results, we look at the accuracy. There is a few interesting findings. Actually, the accuracy of unoptimized code is higher than optimized for counting tasks. That's expected because it's unoptimized. They have more patterns, right, to be observed. For the one is highly optimized, sometimes a chain of calls, the argument don't even appear in individual functions. It's just directly tunnel through. And also the accuracy of AMD 64 is higher than x84 for the instructions. Because they have more diverse instruction semantics, which can form more patterns. So this is the first part on the binaries. And also the second part is our recent work in system audio log analysis. We call it Watson because there's a lot of tasks the researcher or the analyst is facing when they are dealing with the audio log analysis. And a lot of work is done on directly working on the audio logs and extracting information. Then we think a helper will be very helpful, right? So there's a lot of work, especially my advisor Shaker has a paper called Holmes. So it's a detective. And then a lot of detective name is run out. So we decide we don't want to be the detective, but we want to be the helper to the detective. That's why we call this paper Watson. It's extracting information to make the detective life easier. The setting is when, as we discussed at the very first slides, there are also a lot of APT attacks. After attack is detected, people use the endpoint monitoring system like a Planck and Elastic logarithm to record the audio logs and process the audio logs. So they record a history of events, typically at the OS levels, and a typical log is look like this. Right? It's a syscall, and what's the message, what's the argument, and what's the call number, and the process ID and author ID, etc. And the researcher take this log and build a provenance graph. Basically, they say, oh, this one is one process read a file, right, or read from a socket. Then they have a lot of such things pieced together. That's formed the provenance graph. This line of research started early in the early 2000s. There are a lot of work building graph and doing the backward and forward tracing, such as the back tracer. And naturally, the problem is huge, right? You know, there's a lot of process, and thus there's a lot of logs. And also some process have the habit of dealing with many data flows. When the data flow is mixed together, the analysis and the number of states they need to explore can explode. So that's why there are papers in partition the program so that the log will be partitioned. The analysis will become easier. And recently, people started to use a statistic to propagate values across this graph, try to detect what is going on. A lot of the work, the main goal is to do detection or highlight whether there's an attack going on. And often sometimes we're just curious what is going on in the system without really highlighting whether there's an error or there's an attack. Sometimes we want to understand if there's a new behavior appearing. It's not necessarily to be a bad event. It may be a sign for system failure or a sign for some other interesting things. Let's motivate our approach. So can we abstract the high-level behaviors, right, instead of directly making an attack or triggered by attack while the system is running, right? If the attacker just make some initial attempt without really breaking into the system or without violating the strong security policies, they may get account stolen or make an initial hack, but they don't perform damage as we see in the recent attacks. But this way, if we can make sense out of a very large amount of audit data, that will be very valuable because we can see the drift of behavior, or we can see some suspicious high-level behavior pop up, causing the user behavior to drift. So that will be helpful. And if we can abstract the high-level behavior and cluster them using their semantics, then we will have a very interesting system and the solution to deal with this problem. This project is actually motivated by such an example. Think about one of the internal insider, the behavior changed. They want to send out a secret file from an enterprise network. Suppose this programmer's day-to-day task is just to do software testing. They are dealing with a lot of C code. And a typical behavior is they compile the C code and test it and send to GitHub or another Git account. And he wants to mimic this behavior to get this secret out. Right? What he did is make a copy and try to compile it. Definitely it will fail. And then commit to a Git and then submit out. Right? So all the sequence of behaviors is just very normal. Normally it's a day-to-day task. And after the information is out, if if people is observing, it looks normal. And if they know some file is out, it's also very difficult to make sense out of this audit the provenance log. For example, we can see there are a lot of nodes. Right? For example, this the program compilation and upload, the day-to-day task, and Git submission. And when the people set up system, they can do some package installation. And when the data exfiltration is made, this is the sequence of behavior state, very similar to this sequence, but the meaning is actually totally different. Right? How do we detect the new meaning from seemingly similar low-level behaviors? I think that's one of the challenge we are facing. So there are a few important things we want to address. The first one is how do we know the event semantics? Because they are essentially using the very similar program and similar behaviors, but they use them for different purpose. And we log the general purpose activities, and we want to see the hidden high-level semantics. Yeah. Because both the data exfiltration and the program compilation upload, they both use the same sequence of calls, right? Like CC and Git. And also, how do we define what is the individual behavior in the system? So the log is overwhelming, and how to make sense of the clues. Okay. And also the events are highly interlinked. So we have the following insights. Think about what's the difference during the compilation process. If we compile a CC A.C, then you first generate the assembly file, and then the object file and A.out. If you compile another program, right, B.C or another A.C, you go through a similar process. Although the file generated on the temp is different, but you know as the sequence follow through, each stage actually has a semantically similar meaning in these operations. That's why the contextual information is important. But for the data exfiltration, if you copy a text file, the compilation will definitely break, and then there's no follow-up actions. If you look at this chain of actions, then it gives us a sense of what is going on and what's the meaning of these operations. So that's the key insight. We want to use the context in the dependency graphs as to review the semantics of the operations. And also to identify behaviors, that one is a relatively simpler. Typically, the behavior starts with a task. Task often starts with a file. We just trace how a file flows through a sequence of programs. Then the sequence of events, data dependent on the original object by information flow, we treat as the same chain of events form a behavior. Okay, so that's using the information flow on the data objects, we can group the event actions into behaviors. So with these two important parts, we describe our Watson system. We construct the provenance graph not as a graph, but we use the knowledge graph from recommendation system as the way to represent data, because there are more techniques in that domain to be used to extract information from the relationships. And also it helps us to capture more information in the future. Not only the process and the file information, we can capture more properties. The all can be considered at the same time to form the context information. With this knowledge graph, we go for the behavior abstraction. We infer along the graph and see what are the meanings of the nodes based on the individual nodes' relationship with the neighbor nodes. And after that, we aggregate the behaviors along the information flow path and represent the behaviors by classifying them.
Just a second, 5 minutes left.
Okay, great, I'm finishing. So then we have the first step is we represent the graph is a knowledge graph, and we use the recommendation system definition of a knowledge graph and embed it to review the meanings. And also doing the embedding model, we are using since we are focusing on the head and relationship on the tail. If the head and relation are similar, the tail will be similar, right? So, for example, if a CC operates on a file, generate a .s file, then this should have similar meanings. That's why we choose this relationship to encode the semantics. After embedding, you can see we have very interesting behaviors because in the events, we just purposefully ignore these meanings as the previous project. After this embedding, you can see we can group similar activities or files together. For example, this socket connection is clustered similarly in the space. This is the sockets, and this the files. And also, if you look at the left, and then the editors are here, and Git input, right? The Git commit and add is the local operations, and git push and SCP and wget is a network operations. They are clustered together. So that's very interesting aspect. So that's how we uncover the individual semantics from the graph. And after that, we use the information flow. We aggregate them together. So that's how the behavior summarization works. We perform a traversal along the information flow path and aggregate the behavior together. So after that, we have a representation of the semantic meaning of the two. Of the two behaviors. The semantic meaning definitely is an encoded number. Is not a human readable. Is not a human readable behavior. And after that, we do the aggregation and we remove the non-important information and remove the noises. So that's some polishing and post-processing. After that, we can identify a representative behavior for each clusters. For example, in the examples we mentioned, if the employee is just doing the day-to-day activities, the behavior will be clustered into the same group without any anomaly. If there are behavior drifts, it actually can be easily picked up and for the investigator to look at. So after attack has happened, that will be will make it easier to identify what are the breaking points, because there will be a larger number of normal behavior, and this attack behavior will be outliers. Then we measure the efficiency using the DARPA data set. And through our method, we can see there's a lot of reduction in workload and behavior if with and without our, with and without our approach. So it actually can achieve the reduction of 2 orders of magnitudes. So for like this Watson from the workload will be this, and if we summarize into behavior, it will be this. And this is the original ones. If you look at the number of events, and this is the reduction we got. So in summary, recently we are digging a lot in systems to look at binaries, to look at the system events, to feel what is the big elephant look like. And in supporting many analysis, we have a line of work under the principle of inferring the semantics meanings from the value observations. We have a Eclavia one to infer the meaning from the binaries and get function signatures. And also we have the Watson to help analysts, help the investigators to find the high-level attack behaviors to simplify their task. Yeah, thanks.
So I think we go to the next speaker, and my colleague Thomas Walter, I think he's going to introduce our next honorable speaker. I know him as well, but I think physics meets physics is better. So Thomas?
Yes, can you hear me?
Yes.
Thank you, Ahmad.
Yeah.
Yeah, after yesterday's demystification of quantum physics, we will have the opportunity to dive into the topic a little bit more. It's my distinct pleasure to welcome Gerd Leuchs to the Crossing Conference. He is Professor Emeritus of the University of Erlangen and Director of the Max Planck Institute for the Science of Light. He's been awarded with a large number of prizes, among others, the Herbert Walter Prize, and the name is not a coincidence with my last name. Gerd is an integral part of the QNet initiative, and what is all behind that, he will tell us in his talk. And of course, it's highly appropriate when being part of QNet that he is talking about the practical aspects of quantum key distribution. Gerd, welcome here at the conference, and the floor is yours.
Also welcome from me. Thank you.
Thank you, Thomas and Ahmad. It's a great pleasure to be with you today. Quantum aspects of our nature is one of my hobbies, has been a hobby for a long time. and I'm appreciate your invitation. Thomas, I have to correct you. I'm no longer a director at some point I thought I had a lifetime position, but then I understood at some point you have to retire. So this happened.
That's a big mistake on the Max Planck Institute's part.
Absolutely.
I agree. I tried to convey this message, but it was not well received.
I don't donate to Max Planck anymore.
Yeah. Okay, so I'll share my screen. Okay, my long-term companion in quantum communication is Christoph Marquardt. He used to be a group leader in my division as long as it existed, and now he is independent. Okay, so why is it not? Okay, so modern key distribution has to be quantum safe against quantum computer. And you can do this in the traditional way that you know very well about by mathematical complexity or by physical laws. So mathematical complexity means you have algorithms with asymmetric computational complexity, and this whole post-quantum cryptography falls under in this category. By physical laws, this is using quantum physics. And since you are not quantum physicists, I thought I'll try to start with the basics in the first part of my talk. And in the second part, I will show you some pictures of this QNet, big QNet project. So quantum communication is about Heisenberg's uncertainty. It's about the entanglement, and Einstein Podolsky-Rosen Gedankenexperiment, because entanglement leads to some kind of mind-boggling thoughts. Behind this, you could also say, are quantum correlations, and even lasers play a role, because a laser puts out a light field, which is a quantum state. So in the prelude, before discussing practical aspects, let us look what is so magic about quantum systems. So quantum wave mechanics, there's Heisenberg uncertainty, and depending on what system you study, initially people started studying mechanical systems. So you have a position and momentum. Momentum is mass times velocity, so essentially velocity here. And the variances of the two, when you multiply them, they cannot be zero together. That means the product has to be larger than a minimum value. So if you use this typical quantum relation, P equal to h bar k, so P is this momentum of a particle and K is 1 over the wavelength. So this relates relates the wave nature to a massive particle. And this is the famous relation, which basically is an experimental observation. And so if you replace this, you will get a relation delta xk, so the position variance, and this wave number variance, which is related to the momentum. These two variances are larger or equal to 1 over 4. Now let's go to, there are other wave phenomena which are in the classical world. I forgot. So if you have a particle, maybe if you want to describe it as a wave because it has some localization, then it could be such a wave packet here. So wave packet means a wave that has a starting point and an end point. This is now in time. Of course, if you would let the movie run, it would be moving in time. So such a wave packet has much of the nature of a particle because it's confined in space and it had some momentum and so on. In quantum physics, you don't see the wave oscillations, so you are more related to the envelope of this wave. But by indirect evidence, you can make experiments showing there is this underlying wave. Now, in the classical world, you have so there's frequency and time, or space, and then spatial frequencies. So if I stick with the spatial in the spatial domain, there is a space bandwidth product, which is same as the time bandwidth product if I think about times. And there you have the same relation, delta x squared, the variance, times the variance of delta k squared, k again being 2 pi divided by the wavelength, is larger or at most equal, at least equal to 1 over 4. And this is a relation that basically comes from the Fourier transform relation between the position space and its and momentum space, or the time space and frequency space if you're in this domain. And so this is typical for all waves, independent of whether it is quantum or classical. So be it water waves, light waves. So in light waves, you have a similar situation. You cannot see the oscillations directly, but there is indirect evidence. And when you measure intensities, this is more the envelope. But if you go to water waves, you can, of course, see the individual oscillations. If you're interested in these similarities, I gave a talk at the Renner School a while ago. But now we are more interested in what is the difference now? It seems to be all very similar. Of course, there are mathematical details because the underlying differential equations that describe the different wave phenomena, the matter waves, the light waves, the water waves, they are different, but these are details. I mean, otherwise they are all wave phenomena and have these fundamental properties that we just discussed. So what is the qualitative difference, not the quantitative difference in the differential equation? And so let's look at one example of each world in quantum wave mechanics and in classical wave mechanics. So you have a quantum wave and a classical wave, and you want to measure it. So if you measure the classical wave, so if it is light, you don't see the oscillations, you only see the envelope, but the result of the measurement of a classical light wave would be that you see the whole envelope. Or if it would be a water wave, you see the underlying blue ridges and valleys of the wave. And if you, so basically you could take a camera and take a picture and you would see the whole wave. And if you would do it again, you would repeat the experiment, it's the same what you see. Now in quantum mechanics, this is different. So if you make a position measurement, as you would do it with a camera, for example, you make a measurement from which you can tell where is the wave. So in the classical world, you see the whole wave and it has some spread, hence some variance and so on. In the quantum world, so if the quantum wave is spread like this, the position measurement will give you only one answer. So this is strange. You do it again and you get another answer and another answer. Oops. And so if you take many such answers and you kind of plot them all together, basically with the probability to see this or this position, you eventually recover this, this envelope. So the quantum measurement process is the thing that is really different. In physics, we call this the collapse of the wave function. Instead of having this extended wave function, after the measurement, it looks much more confined here. Or some people say collapse sounds like there is some underlying dynamics, which is probably then, which we probably don't have. So the quantum measurement process you have to get used to is one way of saying it, or you can say, well, maybe is it really so well understood? So people are still thinking about this, but this is the evidence. And if you do these measurements repeatedly, you get all these different answers. So in each single measurement, the main effect is that you lose a lot of information. Initially, you have the information about the whole wave, and then you get only one little peak here, which only if you repeat this many times, you eventually recover something like this wave packet. So in general, the quantum measurement process does not give the full information about the state of the system. And instead of collapse of the wave function, some people prefer to say in the quantum measurement process, there is a projection. So can a quantum measurement process, I mean, is it 100% necessary that you lose information? So that is not true. So there's an exception. If the system is, now this is the mathematics theoretical language, if the system is in an eigenstate of the measurement operator, here in our example it's position, then you get the full information. And it looks like this. So if an eigenstate of a measurement operator, of the position operator, would mean that the wave is confined to one kind of more or less one physical point, not a mathematical point. I mean, in physics, you always have to have some finite extent, but as small as can be. So if it is really confined in one particular position, and then you do a measurement, you get exactly this position. So then you're fine. Then you don't really lose information, or not much. And so if you would do this for an atom, and you have energy eigenstates, and you measure the energy of the atom, so an operator that measures energy, and if you know that the atom is in one or the other energy eigenstate, so the atom would be in a state which is an eigenstate of the measurement operator, then you, as an answer, you get one or the other energy, and this is exactly the full information. But of course, the atom can also be in a superposition of different energy eigenstates, and then if you measure the energy, there's this projection, and you only get one value, and you lose information. So in this sense now, this wave packet is a superposition of many position eigenstates, and the position measurement gives you only one of the eigenstates. So now in quantum key distribution, you don't work with position and momentum. I mean, we could discuss this. The momentum is a bit cumbersome, because if you have such a narrow distribution in momentum, you have a very wide distribution if you have a very narrow distribution in position, you have a very wide distribution in momentum. This is this Fourier relation. And that means that if you look a fraction of a second later, the wave will have moved far away. So for this conceptual discussion, I thought I used this position, but if you try to do these experiments, this position, looking at the position is not a good example. I just wanted to give you this as a small side remark, as a warning. But the main message I wanted to tell you is that in all these cases, information is lost when measuring. And when you first hear this, this is true for anybody, also physics students at some point hear this for the first time, you wonder, how can this be? And you try to come to terms with this. And in school, and in many places, people talk about wave-particle dualism. And so here you have the wave, and then they say, oh, okay, this answer looks more like a point-like response, so this is a particle. I don't like this, because you use two classical pictures, a wave, like a water wave, a particle, like a bullet, to explain something which cannot be explained so easily. So I don't like this. I prefer another way to think about the quantum measurement process, which is more hinged on the fact that you miss, so you lose some information due to this projection that happens, this magic projection that nobody can really explain. But I mean, this is true with many laws in nature. You observe nature and you find some laws, but to say, why is the law like this and not in some other way, often you cannot explain this in basic terms. So you have to accept the observations, the laws that you find. But there is a way for us in our classical world where we grow up, to get a little bit of feeling for what happens in this quantum measurement process. And for this, I want to show you a picture from the real world. You all recognize this. It's a tricky logo of a manufacturer of a product which is for for most of us costs more than a monthly salary. And this logo is a bit tricky. So if you look at it, it seems to show some geometric figure which does not exist. I think you probably all see this. If you don't, I'll try to help you. So I'll block the upper part. So now this seems to be a frame which is open to the left. But if I block the lower part, now it seems to be a frame that is kind of open to the right here. So I think you all know such pictures. There are many pictures like this. A more abstract version is probably such a cube where you only see the edges. So this picture, so here when you look at it, your brain can either see this cube or this cube. Different orientations of the cube, but not both. So basically you can make your brain switch, but I don't know anybody who can see both these cubes at the same time. So in a way you could say in these pictures, it's by, in this case, it's by leaving out some information, only showing these edges. You have kind of reduced the information about the picture so much that these two pictures have kind of the same, are embedded in this cube where you can see all the corners, all the edges, not only ones that are in the surfaces that are associated to the surfaces that point to you. So in a way, I think what our brain does is a little bit what happens in the quantum measurement process. There is a picture which contains information, and when you look at it, you only see one part. Now, the brain can, in the brain, you can let it switch. So this is not true in quantum physics. In the measurement process, you cannot let your brain, the measurement switch. Once you did a measurement, the system is in this one state, and if you do the measurement again, then it will be again in this state. So you have this projection, and from then on you have changed the state of the system. Entanglement is superposition of several individually addressable quantum systems, and you can also use these cubes here. So these three cubes would be an entangled state that you could write as cubes of this sort. So this is the typical brackets that we use in quantum physics to describe a quantum state, plus this here. So I think if you try to look, if you're looking at these three cubes and you try to see one of them, so your brain will see one of them, and then very likely, I think all the others look the same. And when your brain switches, they all seem to switch. So it's, don't take this too seriously. It's just a way to kind of come a little bit to terms with what happens in the quantum measurement process. So basically you could say there is more information than you can get out in a single measurement. And the thing is, if you know that your system is in a state which is an eigenstate of the measurement apparatus, you don't have the problem. But if you are dealing with quantum states in general, if not only the eigenstates of your measurement apparatus, then you face this problem where you lose information. Now let's go to more to the physical scenario that people use in quantum key distribution. And often people use polarization states of light. So polarization is the light is an electromagnetic wave. And so if many detectors detect the electrical part, so people often think just about the electrical part of the wave. And so the electrical field is oscillating, and in some simple scenario, the wave may be oscillating just in one particular direction, perpendicular to the propagation direction. And this orientation of the of the electric field vector, the direction in which it oscillates, this is called the polarization direction. So if you have a polarizing beam splitter, which kind of sorts horizontal and vertically polarized light, so if it lets horizontal light go through and vertical polarized light is reflected, so you separate the two. And then you can send in either horizontally or vertically polarized light. And then it's clear you send in horizontally polarized light, then the upper detector will click, and vertical, the lower detector will click. But if you send in some other polarization direction, and there are many, of course, you can choose any angle, but if you choose the diagonal or the anti-diagonal, D or A, then if this is a single photon, then only one of the detectors will click, but you don't know which one, because there's a certain probability for one or the other detector to click. So if you put in, so you have this measurement basis is HV. This is the basis defined by the beam splitter. Now, if your input is H or V or A or D, you have this table here. And here, if you measure in the HV basis and you put in A or D states, then you are exactly in the situation that your system, is not in an eigenstate of the measurement operator, and then you lose information. If you put in the H or V state, then your system is in an eigenstate of the measurement operator, and then you get 100% right results. Okay, so quantum key distribution is about using non-orthogonal polarization states. Non-orthogonal means because the eigenstates of a measurement operator, they're always orthogonal. That's always an orthogonal basis. And non-orthogonal means that you are in a superposition of eigenstates of the measurement operator. And now, in order to turn this into something useful, there are different strategies. And I think unfortunately, I was at a different meeting yesterday, so I couldn't listen to the talks yesterday, but I think Johanna yesterday morning talked about the BB84 protocol, and that is the first strategy I want to mention here. So in this first strategy, you prepare either of four states, H, V, A, or D, and then you measure either in the HV basis, this is one orientation of the polarizing beam splitter, or in the AD basis. So for this, you have to rotate the beam splitter by 45 degrees, or there are other tricks. You can also use wave plates to do this. So now, if, as we discussed before, if you send in H or V and you measure in the HV basis, you get precise answers that you can rely on. If you send in H, A or D and you measure in the HV basis, it's not precise. You lose information and you cannot tell was it A or D or what was it. But if you measure in the AD basis, now you can tell whether it was A or D. But if the signal were H or V, now you cannot tell what it was if you're in the HD basis. Now in this protocol that Johanna described yesterday, you need random choices of the basis for the sender and random choices for the basis of the receiver. And then afterwards on a public channel, they can exchange their information and they say which basis did you use at what time? And then they select only those times when they accidentally had used the same basis. And then they say, okay, we only use these data, and then they know this is very precise. And an eavesdropper that try to look at the data will then have a problem and will have less information. But I think this was discussed yesterday. So this is one strategy, but there are more strategies, and I think it's important, especially when you try to go into the practical world, it's important to see that there are other strategies. Before I come to this, I wanted to emphasize that we have done something on random number generator, because the random choice of basis requires a very good random number generator, and a very good way to produce truly random numbers is by using this unpredictable behavior that happens when you have this projection process in a quantum measurement. Some companies even sell random number generators based on the quantum measurement process. And this is fairly good because in principle, if you have some way to produce random numbers, you can test for how random they are. So there's die hard, and there are many other tests, I guess. And if in the end you come to the conclusion that this long sequence of numbers that you have is really random. But can you be sure that this exactly same sequence is not also in the hand of your adversary because he was spying on you while you were looking at this? Can you be sure? Now in the quantum world, if you make sure that your system is in a pure quantum state, and then you do the measurement and the projection gives you this randomness, then you can be sure that nobody else knows this. Because if someone else knows this, that means secretly this someone else would have had to have some interaction with your system. And this interaction will entangle the system that you look at with the system of your adversary, this hidden adversary. And if you look at a subsystem of an overall entangled full system, then this is not pure. So by looking at the purity, you know it cannot be entangled, cannot be quantum correlated with any other system. So I think this is a very good feature of quantum random number generators, but that's only a side remark. Second strategy, you don't really need 4 states. It's enough to need 2 states. But now these 2 states have to be non-orthogonal. I mean, you have to have some non-orthogonality, as you had also in strategy 1. But if you reduce to 2 states, then these 2 have to be non-orthogonal. And if you are now in this polarization domain, if you use polarization, then you can, for example, use A and V, or A and H, or D and V, or D and H. So one of the left 2 and one of the right 2. And so suppose we have some which are 45 degrees separated. So I chose these odd angles here just to make them more or less symmetrically around the diagonal, I guess. I don't know. So this would be 22.5 degree is with respect to the horizontal is this one state that we are sending, and 67 degrees the other one. Now, how would you now go about to do the measurement? And there are different strategies. One is unambiguous state discrimination. So you discriminate the 2 without making a mistake. But that means you have 3 outcomes. One outcome is it's one state. Second outcomes, it's the other state. And third outcome is you cannot tell. So you have these 3 outcomes. And how you do it is you measure in either of 2 bases, either the basis of which this 67.5 degree vector is part of. So the red is orthogonal to the 67.5. This is minus 22. There is 90 degrees here. And the other basis is the 22.5 degree, and it's normal, or it's orthogonal state. Now, if so, you would measure with polarizing beam splitters. So if you are in this red, this minus 22.5 basis, you could either see a signal which would tell you, I measure 67.5 degree or minus 22.5 degree. So if you measure 67.5 degree, it could be this signal or this signal. There is a large overlap here. So this is inconclusive, then you don't know. But if you get a signal out of the output port that tells you there was minus 22.5 degree polarization, so this this polarization gives you a signal. That means it cannot have been the 67.5 because that has zero projection onto this basis. So it must have been this one. And likewise for the other side. So you get, in some cases, you get conclusive results, and then you have in many cases inconclusive results. So this is called unambiguous state discrimination. There's actually a tutorial, a nice tutorial about discrimination of quantum states by Janos Vagu. And of course, there are some other papers on this, but that's quantum state estimation is a big topic. The other one is minimum error discrimination. Now you use all the measurement results, but it's not completely conclusive. So you will make errors, but you minimize errors. In this case, if you take the same two polarizations, then what you have to do, you have to measure in a basis, which is, of course, two orthogonal directions, the measurement that you can do with a polarizing beam splitter, and you range it such that it is, the basis states here are symmetrically oriented with respect to your two signal states. Then if you do a measurement, you get some signal all the time, but if you measure vertical on this axis, this is for vertical, then it is much more likely to be 67.5 degree signal than this 22.5 degree signal. But of course, you get some false alarm here. And then you have to do privacy amplification, or you have to use some techniques to get the information out. And an eavesdropper, if the eavesdropper will do some measurement, of course, the eavesdropper, when it does a measurement, it's also subject to projection. So he changes the state, and so there will be more errors. And this is how the eavesdropper can be detected in either of these strategies. Okay, so lastly, when you are following this minimum error discrimination strategy, you can also, you don't have to work with polarization, you can work with any other quantum states you can think of. For example, also with coherent states. So coherent states are the states that ideally come out of a laser. A state was at the same time minimal amplitude and phase fluctuation. And this is a so-called phase diagram in electrical engineering. It's often called the two quadratures I and Q, which are 90 degree out of phase. Or you say this is the real part and the imaginary part of the electric field if you use a complex description. And alpha is the complex amplitude and phase of the coherent state. And now coherent states are Gaussian distributions in this phase space, and if they are close enough, they are quite non-orthogonal, and there are ways to discriminate between the two. And this falls in this minimum error discrimination, where you have to then add privacy amplification. So if you want to measure the coherent state like this, you need a local oscillator, so that may be a bit cumbersome, but you can go to two modes, two polarization states again, and use coherent states of these two modes. And this is the Poincare sphere with its 3 Stokes parameters, which describes nicely the polarization state. And now if you want to use coherent states, then if you combine it with polarization, you can have them close by on the surface of the Poincare sphere. And then just by doing simple intensity measurements using polarization tools, you can do the measurement without the need of a local oscillator. Or you could say that in these polarization fields, the separation from the origin, there's power in this, there's some mean field in this separation, and this is like the built-in local oscillator. So from a practical point of view, this polarization of light gives you also here, gives you a good advantage. And this is something that is quite useful when you want to do it practically. So when you work with such coherent states, either in normal phase space or in this two-mode polarization space, then people talk about continuous variables because the position or the orientation of these coherent states can vary continuously in phase space. So the quadratures are continuous variables, as opposed to when you are in the in these other strategies where you have only two, when you have these two orthogonal states, like a single photon and a one photon state, or a one photon state in one polarization and a one photon state in the other polarization. Then you have the discreteness of the photon numbers, and then this is called discrete variables. So this is just to show you that we have done things like this here in Erlangen. This was our old building before we moved. And this is the computer science department of Friedrich Alexander Universität. So this was, what was it, 1.6, here it is, 1.6 kilometers. And here we used coherent states on the Poincare sphere, and we showed that this works quite well, partly because the air is not birefringent and doesn't change polarization, so that worked quite well. If you want to go long distance, so this is the Earth here. If you want to go from, let's say, Iran to Spain or so, this is several thousand kilometers, and in fibers, this is difficult. You cannot do today. But there are satellites, so there are low Earth orbits, which people are work with now, but they move fast. But you could even think of stationary orbits, but of course they geostationary orbits, but of course they are far away. This is about to scale. This is 13,000 kilometer diameter of the Earth, and this is 40 something thousand kilometers. So now, what about fiber link versus satellite link? So fiber link looks much shorter. Should this not be better? Now, the problem is the attenuation in the fiber. This is exponential because of losses. This is at most, at least the best fibers have probably 3 dB per 20 kilometers. And so you lose. And if you have too much attenuation, the quantum key distribution is getting harder and harder. If you go via outer space, there is of course the atmosphere, but this is only the first few kilometers, and then the other 40,000 kilometers is through empty space. And the only thing why you lose is that you have a diffraction limited. I'm looking at the time, I'm probably speaking too long. What is it? Oh my God. Yeah, I have to stop quickly. The only way you lose is because the beam expands and expands. So Rayleigh means the Rayleigh length of your focusing of your telescope, the mode that comes out of the telescope, divided by the full length, which are the 40,000 kilometers. And if you do this, this only goes down like 1 over the square of this ratio. And this is much better than to have an exponential scaling, as we know. So if you say, well, maybe 50 dB is the limit, then you're limited to 250 kilometers in a fiber. But if you want to go even via geostationary orbit, you have to specify how big your apertures are. So if you have a 60 centimeter telescope, which is probably still feasible, then you also have 50 dB, but then you can basically go from one side to the other. Maybe not quite, because you go under grazing incidence into the atmosphere, but a few thousand kilometers is no big deal once you are in this regime. So in 2007,
just a second, 5 minutes left.
Yes,
thank you.
Thank you. So in 2017, we did a measurement to the Alkassar, which is the Alkassar is a satellite, European satellite that carries a laser communication terminal, LCT, built by TESAT, and it's owned by DLR. And so we use this system, and using these continuous variables, the technology is very close to the classical optical technology. So without changing anything on the satellite, we couldn't do quantum key distribution. You couldn't distribute the key, but we could characterize the quantum channel, whether there is too much classical noise that would prevent this. And the result was, this is good enough. In principle, one can use this. And shortly after, the China put up this quantum satellite, and they are a step ahead. They actually distributed the key from this satellite. Now, just a few quickly, so my introduction was my whole talk. Why did it take so long? Okay. So this is QNet, this project status and perspectives. Let me see. So in QNet, we are using both post-quantum cryptography, especially at our DLR partner. Oh, I forgot to say there are two Fraunhofer institutes, DLR in Oberpfaffenhofen and our Max-Planck Institute is involved. So we will use a combination, the best of two worlds, post-quantum key distribution, post-quantum cryptography, and this quantum key distribution. So post-quantum is a complexity-based, and quantum key distribution is the physics-based, because you have the problem of authentication and so on. So it's good to combine. And also you need a quantum channel for this year, and maybe you don't always have quantum channels. So the aims of QNet, so this is detailed, so now I don't have the time to go through this. Maybe the best thing is to go to this slide here. So you can buy QKD systems from companies, but this is A to B in a fiber. Now in a real system, probably you want to combine a fiber with a free space link, or you want to just use a free space link and you want to use different wavelengths. And so there are all kinds of technical engineering problems that you still have to solve and you have to do. You also have to talk about certification, and so the BSI, Bundesamt für Sicherheit in der Information, is involved, and so it's all about this step into a real practical system. This is the initial for first demonstration. We started with an 800-meter link, either by fiber or free space, and there was a demonstration. I saw you some pictures of this. So the whole project is scheduled for 7 years. The idea, so we have these research institutions that starting this, and the idea, the BMBF is interested, of course, in involving more and more industry, and quite a number of industrial partners are already highly interested, and so we should kind of gradually transfer to industry. And basically this is about key distribution, but also eventually with these quantum links, you could also link quantum computers. There's these links that one will set up can also be used to synchronize quantum clocks. Maybe one of the initial ideas about quantum technology was about quantum money. Maybe we come back to quantum money at some point, and quantum memories. Quantum memories actually can be helpful to make fibers more viable via some quantum repeater. You can go to longer distances that I told you before. Okay, so these are pictures from the 10th of August demonstration. This is Minister Karliczek, who was there and spent more time than her assistant announced she would, because she was interested. This is in BMBF in Bonn, and there is a telescope looking over towards BSI, which also is in Bonn. And this was, I forget, probably a kilometer or something. No, this was these 800 meters, yeah. And so these are some impressions. That's a small telescope by DLR, but Fraunhofer had these are on the first picture. That was a telescope by Fraunhofer, slightly larger at a different wavelengths. This is an entanglement source where the entangled photons were also distributed. So this worked fine, and so everybody was happy, and we can continue. Thank you very much.
Good day, everyone. Again, we are back on track. I know that you had a very a short break for lunch, but you know it's virtual. You don't know who is watching. You don't know how people are watching, and you don't know what they're eating. So that's a good thing with it. It's a pleasure for me to introduce Igor Linkov, whom I know for some time now. And we had the pleasure having him in another workshop that I organized on pandemic, with an amazing, interesting talks that I was contacted by several participants saying that was a very eye-opening talk. And Igor is a threat analyst, and Igor has done has a background in physics, has background in environmental aspects. And he's currently U.S. Army Engineer Research and working in U.S. Army Engineer Research and Development Center. And he's going to talk about AI for security and resilience and resilient AI, because these concepts are very much linked together. We are using currently, because of the AI hype, also using AI for security and resilience, but AI itself has lots of problems. So how about the resilient AI, which is a hot topic of research currently in security community? So I'm very happy that Igor could make it, although it is very early on his part, but he said it doesn't matter. And I see that he has a collaborator who is called Benjamin Trump. I don't know if it is related to US President Trump, but anyway, it would be nice to know if he went to Trump University. Please, the stage is yours.
Yeah, thank you very much. I wish Ben was related to Trump, then maybe I would get more funding under Trump administration rather than basically be killed. Because as you can see, I am part of environmental lab, and funding was really slim on environmental application.
Yeah.
And we are obviously federal government, and I'm part of research arm of what is called Army Engineer Research and Development Center. Even though we are part of Army, we are basically a civilian organization. 98% of people of our workforce of 35,000 people is civilian. Research arm has 2,500 people, budget over $1 billion. And for all reason, we are just normal research organization. We have 7 lab. I am part of environmental lab. My team is actually in Boston. And recently I was promoted to take over a portfolio of work for the whole organization in crisis management and resilience. So, with that introduction, I have to say that I am not computer scientist. I'm not AI expert. My background is in physics, but I kind of progressively moved to social science. And in my job, I'm trying to link physical and social science to address emerging challenges. With my physics background, of course, I'm always trying to use numbers and quantify things. And with AI, I clearly see the need. AI is a great tool, and I saw many presentations in the agenda, and I listened to a couple of them yesterday in your conference. But it's very different in applied world, right? So when you start talking to real decision makers about application of advanced analytics, not necessarily AI, but any models, you basically hitting a lot of resistance. Decision makers needs to intuitively feel this decision space. And whether it's military commanders or civilian decision makers, they really try to make sense of what's going on. And often in AI presentation, I feel that, especially when people who come to AI from applied world, they say, well, we have this problem, and then we hired this group or consulting company, and they have AI, and they tell us that solution is X. And when you start asking questions, why it's X and not Y, it doesn't make any sense. The answer you're getting is, well, but AI tells us that it should be this way, and we trust it. So it's obviously the wrong way to present results and the wrong way to address real decision challenges. Just an example, Ahmad initially asked me to talk about pandemics and all that, but there are no space for AI there, and I saw that you guys primarily focus on AI. But what I like to say is that my team get engaged in pandemics from really day one. We are in Boston, in New England, and in the US, emergency response is done by FEMA, and FEMA split in regions, right? So in New England, we have 6 states, and FEMA Region 1 is in charge of that. So if you remember, initially we had increased number of cases, and in March 2020, it was not clear how fast will it go and what is going to happen. So I was contacted by FEMA, and they asked, well, we need a statistician to look at the data. Can you help us? Probably it will take 2 weeks. And I said, well, yeah, of course. And immediately I realized that they need a lot of help. In the whole region 1 of FEMA that covers 6 states, they had like one person responsible for data analytics. And she was really bright and very nice person, but she's a lawyer by education, right? So you have one lawyer responsible for data analytics for the whole emergency situation of major proportion. And it shows how much data analytics is used in support of real decisions. And we're not talking about the AI, we're talking about basic statistics. So just to finish pandemic side of that, we had like 4 people working full time. Very quickly I convinced FEMA to hire half of my team at that point. Yeah, we're still there. They extended our engagements through March 2022. So it will be like 2 full years. But coming back to this, yeah, you need to do something with AI tools if you like to make an impact on decision making and on the practice. So DARPA, and I'm using this old slide, they had this initiative what it's called explainable AI, right? They say, well, okay, we need to explain what AI does to decision makers. And this is kind of snapshot of what they had in mind. You start with data, you train data in AI model, you go through all that, and you deliver it to decision makers. And as I said, that's wrong because it's like a black box, right? So instead of just delivering results to decision makers, they say, well, we need to have a model that explains that, and they call it explainable AI. The problem with this approach, though, is that you force logic of a machine and logic of humans, and you are limiting. First of all, it may not be correct, right? AI may use completely different ways of solving the problem than human would do. So try to explain how AI algorithms solve the problem might be different from how human would approach the problem. So it's artificial to start with, but also fundamental problem is that humans, it's not like humans and decision makers know how to make decisions. They use all these cognitive models and tools, and they really don't know. We make decisions in a different way. So what I'm trying to do in my work, for example, even without AI, I'm trying to link decision models, which captured in the field of decision analysis, with physical models, which are physics-based or mathematics-based or AI-based. And in intersection of this value-driven decision model and quantitative models, you can make what we call interpretable AI. So in this paper that was published like 1 year ago, we argued that explainable AI is not sufficient. You really need to bring decision models and cognitive side of decision makers with AI to make sense of that. You need to bring humans here, not just unilateral direction from AI to humans, but rather both ways. And then on top of that, we argue about resilience here. So it's not enough to really connect AI and decisions. You need to place it in changing environment, right? You have threats and you have dynamics of the system, and often you represent that as a static solution, not just with AI, but with any model. So what we argue here that you need to have AI squared, which is actionable and interpretable AI. So even though I put in the title resilient AI, I primarily will be talking about how AI can help resilience. Resilient AI, it's a relatively new field and not much is done. And I'm actually funding a project now when actually it's with a company in Switzerland. They look at what it's called robust AI. Basically, it's a well-known phenomenon that you can change AI prediction by very small changes in the training set. So if you put like cleverly a bunch of stickers on stop sign on a road, AI algorithm may all of a sudden change interpretation from stop sign to speed limit of 90 miles per hour. And what they call robust AI is ability to really make same interpretation, even though there are some slight changes in training set. But what they argue is that resilient AI means that these changes may be dynamic. And after all, if I make initial interpretation of this 90 miles per hour, but quickly correct it, based again on decision context and other factors that may help me. But anyway, I will continue here. And as I said, my main hypothesis here that you need to move from explainable to actionable and interpretable AI. And it can be done through linking AI tool with decision analytics and resilience. But an overall framework that we are now utilizing is actually linking all that through data fabric and stress testing. We link AI-driven algorithm that allows detection of complex interconnection in the system and use stress testing to find ability to recover. And that's all new. I have not much to report, but this is like overall framework. But let me start slowly here. What I will try to do, I will try to go through field of risk assessment, which is focused on finding a component of the system that are going to break and hardening them. I will show the efficiency of that approach. I will go through resilience quantification and the role of judgment and different way to quantify it through metrics and network science. I will talk a little bit about how we design a resilient system and role of AI in that. So I think fundamentally, risk and resilience and security often used as a synonymous, but these fields are very different. If you look at Oxford Dictionary, risk is a situation involving exposure to danger or threat. And the way we assess risk is by developing scenario for the threat, finding how this threat scenario affect system and specifically what are the vulnerabilities, and then we assess consequences. If you are managing to act on either threat, reduce threat, or harden the system to reduce vulnerability, you achieve state of security. And it's state of being free from danger or threat, right? If you make system operational, so no matter what's happened, the critical function is within a narrow range that is acceptable, you have reliability. It's quality of performing consistently well. Resilience is very different, right? If a starting point for risk, security, and reliability is system that fully functional, and we are trying to keep it that way, resilience starts when system fails. And resilience is ability to recover quickly from difficulties, right? So fundamentally in the field of resilience, you acknowledge failure as normal thing. But you ensure that you recover fast. And if you think about that, natural evolution of the field of resilience allows us to do that. We do, like, think about vision, right? if I am on the beach and I look at the sun, I'm going to lose my vision completely for a few seconds. But because my vision is very resilient system, I recover it very quickly and to the same level. So from point of view of risk analysis, it's completely unacceptable, right? I lost my function below threshold. And from risk point of view, nobody would allow you do that, right? You have to have sunglasses all the time. But from resilience, it depends on critical function. If I'm sitting on the beach, I can lose my vision without any problem as long as I recover it. But if I am operating a car or plane, I need to protect my eyesight because even losing vision for a few moments it may be catastrophic in that case. So risk is really looking at probability of failure, while resilience is really ability to recover. But anyway, so let's think about how risk assessment can help in cybersecurity context, because that's kind of your interest. And this in this paper that we published last year, we tried to integrate cybersecurity risk assessment and multi-criteria decision analysis, and we argue it's probably the best you can do in linkages of risk and linkages of decision analytics and risk assessment in cybersecurity context. Because if you think about that, risk as a product of threat, vulnerability, and consequences, where you can quantify all of that, is very different for difficult for cybersecurity, right? If you think about hurricanes and floods and all that, threat is more or less known or predictable, and it changes, right? You can have very strong hurricane, you don't know what's happened. But if you build a really large seawall, it's going to protect you. With cyber, even if you build protection, your adversaries will not be looking through the same vulnerability. They will change. So in a sense, you don't need to harden cyber system. You need to have illusion of hardening, and then your adversaries will not do it this way. So what, and this is like captured here, cyber threat is change from this very simple system like back 20, 30 years ago to network connected system. And that slide already like 10 years old, but it's still valid. So risk assessment changed in that situation. Instead of quantifying explicitly risk as a probability, we now have multiple metrics of risk. And what I see in practice, people try to quantify risk based on individual metrics. And then the question is what you're going to do with all these metrics, right? Because that might be a big problem. I use this cartoon from Asimov, and if you have different logics of how you put metrics or assess system, you may have different outputs. So, this is like three laws: don't harm humans, obey orders, protect yourself, right? So, and Asimov insists on this order of execution. So if you do that, you get a balanced world. But if you place more importance on different rules, like for example, if all of a sudden priority is to protect yourself, obey orders, and don't harm humans, you may have very different world, right? And everything in between. So what does it mean that you have different logic of execution? Basically, it's a field of multi-criteria decision analysis. You have, and we have a book, I studied that for a while. It's really your subjectivity, right? There are no objective way to train AI algorithm on what is important for humans, right? It's all subjective, but in the field of decision analysis, you try to capture values of decision makers, of humans in this case, and then you try to assign weights on different criteria and metrics and assure execution based on system of values that humans have. we sometimes, and I've seen it in AI and other field, people try to derive these weights from statistical arguments or from some observation, all that. It's good, it's fine, but there is a difference. You should clearly realize that values are not objective. It's subjective. So you need, at some point, you need to really uh, understand what is objective and what is subjective, what is data and what are values. And values may change. They're different from one situation to another. As I said, system of values about visions and losing vision is very different if you're sitting on the beach or flying a plane, right? So anyway, I guess you get the message. So in this case, I will move a little bit faster. What we've done, we say, well, you have high performance computing, you may have a cyber attacks. So how you structure a risk assessment system? Well, we did threat vulnerability consequences, but instead of trying to assess probability and as a product of this, we try to have individual metrics, right? And then we try to assess what countermeasures you can implement. Hardware upgrades, personal training, handling, do nothing. And you can see that from point of effectiveness, time consumption and cost, they all different. And decision analysis allows you to find which one comparatively is better and why. So insurance against data losses is very effective but costly, while and has some cost. While do nothing is best performing in cost is very cheap, but it doesn't effective, right? So in combination of this, you can select the right course of action. But moving forward, the problem with risk assessment is that it allows a protection of your system, but it's very costly. As I said before, in risk assessment, you're hardening the system in a specific scenarios, and if you're moving to low probability, high consequences scenarios, cost of risk management is increasingly high, right? You're kind of chasing smaller and smaller threats, and something else might be happening. So in this paper, we argued that you need to move from risk to resilience. And the field of resilience actually start growing some 10 years ago. And under Obama administration in the US, resilience was primarily used in the context of climate change, but it also started to be used in the context of infrastructure and cybersecurity. This is like 2013 executive order. Under Trump administration, resilience was used for cyber, and now under Biden administration, it's again all over, and especially with pandemic, idea of resilience are booming now. So, and basically resilience is a property of a complex system, and its ability to kind of minimize losses under performance. So in a sense, what we are trying to do in resilience is to minimize this area under the curve of system performance. But because performance is subjective, right, you have multiple components of resilience that you need to look at, and all these are part of very complex systems. So basically resilience is complex system thinking, and you need to use appropriate models, including AI models. And we capture some of that in our book and papers that published in many journals, including Nature, about resilience and connections to risk. But as I said, it's basically one dot, which is probability of failure and critical functionality versus area under the curve, right? So, and this framing of resilience is actually now widely used. We proposed it back in 2014, but you can see these curves in many resilience papers all over. And moreover, resilience is just one property of a complex system that affected by threat, and there is a lot of confusion in the field how resilience connect to agility, adaptability, security, robustness, safety. So again, I don't have time to talk to that, but at this fundamental level, you can really see this paper and some other papers that we put together. What I like to say a few words about, because that's the right community, is how you quantify resilience, and that may be useful in your work on AI. So in general, you can pretty much quantify everything through metrics-based and model-based approaches, right? In the context of resilience, people use individual metrics of resilience. They connect them in indices or visualize through dashboards. We try to use decision analytics. I already show you an example how to do that. But with AI, you need to move to model-based approaches. And of course, process-based models are golden standard, but we really don't know much about complex system and processes that govern them. If you have a lot of data, you can use statistical Bayesian models, and AI models are somewhere there. What we try to do as a kind of optimal strategy, use network science models, but obviously you can use game theoretical and agent-based and all other models here. With metrics-based model, the best I believe we can do is to really acknowledge that complex system include multiple domain, physical, cyber, cognitive, social. And what we propose in this early paper to reconcile this domain of a system with stages, temporal patterns of resilience. You need to be able to prepare to threats across all this domain. When something bad is happened, you need to absorb, recover, and adapt. And this approach is very scalable. You can apply it at literally individual building levels all the way to countries and global. And there are multiple papers where we've done it, so I will be glad to share this work. But as I show in cyber system, what you do in multi-criteria decision analysis, you try to weigh domains of the system and individual metrics based on your values or decision maker values, and you use it to comparatively assess courses of action. So yeah, you may have baseline resilience, and if you do nothing, your cost is low, but it may be below threshold of acceptability. You can improve your resilience a lot, but it costs a lot of money. You can improve it a little with less cost, but then you need to figure out as a decision maker whether this alternative is better than that alternative, right? It costs more, but provide less resilience. And we conceptually applied to cyber like back in 2013, and we're now working on again a lot of what I do is conceptual. My job is to move the field and encourage people like this group to really think that way. So we published a series of papers in journal Computer, which IEEE Computer Science Society top journals, kind of thought-provoking papers on how to measure cyber resilience, what risk and resilience mean for cyber defense or autonomous agents. So it's all cool stuff. Again, I don't have time to talk about that. But what I really like to say a few words is network-based foundation for resilience theory, because the idea here is that you move from defining resilience as individual metrics to defining resilience as a property of network, as the function of topology of the network, properties of links, nodes, and things like that. And we apply it again conceptually and with some application in different situations. So, for example, how many rules you can impose on cyber system on users. So if you give people complete freedom, they're happy, but you may be affected by cyber threats. Well, if you restrict people's ability, if you demand that they follow, many rules, they start to violate rules just to be able to execute jobs, right? So you kind of see that from risk point of view, this is a situation that you like, no matter how stringent your regulation, more stringent your regulation, less risk. But from resilience point of view, you start to violate the system. So yeah, we capture that here. So if you like to control external threat, you increase number of rules, but you generate self-inflicted vulnerabilities by doing that. So you have this optimality somewhere in between, and the question is how you find it. So yeah, we did like very simple model and simulations that shows like 5 rules is good enough, right? If you have more than 5 rules that you demand people to follow, the system start to collapse from point of view of resilience. If you have less than 5 rules, you may have too much of cyber threat. We argue that, yeah, let me skip that, but in pandemics, it's actually the same story. And this paper was published on the tail end of Ebola pandemics. And we try to study how much of travel restriction and fear you need to increase in the society to have this optimal response, right? Unfortunately, this paper didn't attract too much attention, and the whole, if you remember, after Ebola pandemics and whatever 15, 16, it was not much funding for pandemic research, but you pretty much see that even back then we look at our node that everybody knows what it is now, and we try to show that, yeah, from point of view of risk, if you impose travel restriction, you really always improves risk management, but from resilience, it's much difficult to recover. And still till this day, I don't really know whether initial overkill, or maybe not overkill, maybe that was very appropriate when, we were all in masks and gloves and, I remember washing like groceries bags in early days of COVID pandemics. Where we on this curve, I don't know. But conceptually, again, we were thinking about pandemics of the past, and in this paper published in 2016, we argue that in many historical pandemics, after Black Death, for example, in 1400s, society collapsed, but then we had the Renaissance, right? So many people argue, and we work with archaeologists at that point. She showed that after pandemics, next several generations of people were healthier, and we had Renaissance. So ecologists actually argue that collapses are okay at system level for complex system, like, right? You have forests, it's kind of grows, you have stable states, and then you have forest fire and system change condition from forest to grassland. And from ecologists, this is fine. But we argue that for society, you really don't like to collapse. You don't like to kill like millions of people. You like to find a way through analytics, through AI, to move to a better system state and improve it, right? So I hope that through pandemics, we will be able to do that. But the question is, again, how? And this is where connections of network and resilience can play. How much time I have left? I don't have my clock here.
10
Ahmad,
minutes. 5 minutes
10
for
minutes.
and then
Okay,
Q&A.
so let me move faster because, again, it's all published. So we studied 2 line of research that we now integrate artificial intelligence is this idea of efficiency and resilience of complex system. You see tremendous supply chain shortages and all that now. I every other day come to my grocery store in US in very wealthy neighborhood, and I don't see milk in the shelves. That was really unbelievable for me. And why it's happened? Because our supply chain, everything is optimized for efficiency, right? And when you have disruption, it stopped working. And in this paper, we look at transportation network, and again, it was done before pandemics. We connect a resilience model and network model, and we show that you may have efficiency and resilience, and they are not often go in the same direction. You may, from a traffic point of view, San Francisco and LA are equally bad, a lot of traffic. But if you have a disruption, San Francisco collapses. Well, LA is one of the most resilient cities. Why? Because road network in LA is very good. You have regular grid, many small roads. In San Francisco, you have water, you have bridges, you have stretches of the highway. So if you're stuck here, you're out of luck. You lose a lot of time. So you're not efficient and not resilient. You cannot recover. Here in LA, you can recover. And we show that it translates in GDP losses. And we also show that with cyber attack on transportation, you may be in trouble if you don't have resilience. So basically back to where I started. The question is how you use AI here. And the best value for AI, I think, is to really unearth structure of the complex system. Because we see a lot of transactional data coming, for example, from supply chain, but we don't see underlying structure. Like, why in early days of pandemics, toilet paper disappeared, right? How supply chain and consumption of toilet paper resulted in this crisis, right? I still don't know why and where do we have lack of resilience. With meat supply chain, we had problem with meat, and we figure out that it was actually meat packaging plants. When people start to get sick, meat packaging plants were so efficiently designed that that link was out, and the whole meat supply chain was affected. So you can see that you can easily do that, not easily, but you can do that through AI. And it's, again, I have a couple of slides from my AI team. And I guess I'm not going to talk much about that because you know more. But AI would allow to assess this causal links and process that govern the complex system. And we don't have data. AI can be used to really bridge this missing data situation. And so that's what we are working on with AI-enabled data fabrics and all that to really represent networks and then do resilience analytics. So moving forward, as I said, COVID clearly showed that we need to be ready for disruption, and I really see that AI can help. We really need to have AI to achieve resilience in our system, and we also need to think how AI prediction themselves needs to be resilient. But the idea that we need to represent real world through this interconnected network model and use AI and other tools to assess resilience and find alternatives that can be managed is really important. Another component that it's actually getting a lot of momentum now in our work. We just have a couple of papers in different Nature journals on whether you design system to be resilient or have outside resources so you can intervene. And that's, again, from optimization point of view, it's important. So I think the future is really along the line of moving from highly efficient system that we have to more resilience, where both efficiency and resilience can be utilized. And the way to do that is to integrate kind of this risk-based bottom-up algorithm that go from data collection to management with more top-down algorithm that start with values of decision makers and reconcile them through the models. And I guess that's where your group may be. You can enforce AI through decision analytics and resilience, and then we will be living in a happy world. We published a lot on this. I will be glad to share papers and books.
With that, I will just change to our next speaker, Ammar Alkassar. I would like to take some very little time to say something about Ammar. I want to praise him a bit. Ammar was I know Ammar for many, many years. I also followed his, I see he even has some gray hair. I followed I followed his career very closely. As a student, Ammar was one of the best students in the University of Saarland in computer science, but also engineering. He was, as a very young man, was very active in politics. I remember that we had lots of passionate discussions about politics. So it is not that he's doing it for the first time. He was always very active, and even with together with high-profile politicians, he had contacts. He did a lot of, so to say, eye-opening political meetings with youth in his age at that time. He had the leading positions there as well. Ammar founded one of the, and was a CEO of one of the most successful IT security companies in Germany that was acquired by a much bigger company in 2015. He has run this company from scratch, and that's what I think is very admirable. Since he was very interested in politics, now he's back in a place where I think he can make decisions. He is a state commissioner of state Saarland, which is in the southern part of Germany, and has lots of, so to say, centers like Max Planck Institute for Computer Science, a very top computer science university. And he's going to talk about this aspect of innovation, of digitalization that many politicians are talking about, but maybe they have even no idea what they are talking about. But Ammar is one of the people who I think he knows what he's talking about. And this is why I invited him to give us his view about innovation and whether or not we are losing the game. Ammar, the stage is yours.
Thank you very much, dear Ahmad, for the really lovely introduction. I think I should need to mention that all of this was only possible due to your advice as a supervisor at university, and last 2 decades of discussions and advising. So thank you very much for that. And I'm really thankful for inviting me to this distinguished conference, getting back to my community after being 3 years out on, let's say, in a community which is much more superficial than I used to work in the scientific community. But as Ahmad just mentioned, it is a community where a lot of decisions are taken, and decisions which affect all of us and which affect all of our work, life, and economic situation. And so it is something we need to think about. How could probably the gap be closed between the scientific community and the policymakers and the lawmakers? And I really enjoyed the talk from Igor, and the discussion Ahmad and you and Igor has been doing within the last minutes, as it's really describing the real challenges we will have by addressing innovative technologies, for instance, in the area of of IT security, but also in artificial intelligence and others. And I would like to just introduce a couple of points, a couple of thoughts, a couple of theses to have or to share with you some of my observations I had within the last 3 years, and probably to have some starting point for discussion and to get into to an exchange with you, what you think, what politics should do and what politics could do, and probably to have a short discussion about the shortcomings in the current way we are doing regulation and we are doing laws and things like that. I will try to share a couple of slides with you. Let me see if it's working. So let me see.
Yes, currently.
So can you see the slides?
Yes, yes.
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 Okay.
Perfect.
So let me see if this is working. I'm every time when technology works, it's something you can celebrate. So yeah. So first of all, it was a real challenge changing from somebody changing the sides from somebody who was advocating for years for cybersecurity to someone who needs to take more pragmatic compromise between functional operational requirements and the security itself. As somebody who is responsible for the whole IT in this region, cybersecurity is one part. But if you see the challenges the CIOs are confronted with, cybersecurity will get into, let's say, a position that is much smaller than it should be if somebody is coming from the cybersecurity with a cybersecurity background. Nevertheless, I've started introducing a digital strategy for this country, and the two main issues or the two main points we're running along with is cybersecurity first and AI first, as we are defining cybersecurity as one of the main pillars for the digitalization without having trust in our digital infrastructure. All of the digital issues we want to realize won't become accepted by the people. And that's the reason why we said cybersecurity is one of the main pillars. And we are putting this in all of our projects and all of our initiatives. We are doing this and we are investing significant amounts of money, not only in the securing the digital infrastructure of our administration, but also in putting research funds into developing new technologies in the context of cybersecurity. And so a couple of observations we have, and I will start with something just following the resilience discussion we just heard. Let me see how I would move. Yeah. So the first thesis is that, you know, everyone has been talking since 20 years that digitalization is more of the most important things, and we are going to digital everything. But in fact, it was more or less something which hasn't been in the core of lawmaking. It was not in the core of those people who has been in charge, also in a lot of parts of the government. That changed significantly with the pandemic crisis, as from one day to the other we have been realizing that without a digital backbone, without digital tools, we won't be able to just continue our normal life. We haven't been able to continue our work. and without the use of digital infrastructure and digital tools, the consequences of the pandemic would have been much higher. And this is something, meanwhile, everyone has realized and put as something which is a core part of the future considerations when it comes to policy making and lawmaking and so far. But there is also another very interesting result of the pandemic, which is not directly connected to the digital infrastructure, but it's more connected to the way how we do lawmaking, for example. So usually the public administration is made in a way that it is very risk aware or tries to avoid risks at all costs. That means that the chances are not being picked up, because usually the risk position is much more into the direction of trying to avoid these risks and not to get chances. And this changed significantly within the pandemic situation, because the time factor is getting a very crucial factor. The government was under pressure to take actions, and even to take actions under situations where not all facts and nor all information has been available in a way that the decisions could be the results of the consequences could be estimated to the end. And this is something which really is a really significant change in the way of how governments work. And this is not something which is only an observation for the German government or for governments within Germany. This is an observation for a lot of governments worldwide. And this has severe consequences also, for instance, for the way how we use also digital tools. There have been to get probably the negative impact. That means that for a lot of tools we have been introduced within the pandemic situation, the functional and operational requirements has been much more important than the requirements for cybersecurity, because there has been a massive pressure to move to digital, and the question about the security has been moved to place 2. This addresses this is, for example, relevant for something which is very obvious when you use video conference systems like this one, but also for using a lot of other tools. And this is something we will see a lot of real challenges in the future when the digitalization will come more and more to the foreground, and then we will see people misusing this, let's say, open doors to attack also values, also governmental values and others. And just to see a couple of examples, we had in Germany a couple of weeks ago massive attacks to community administrations, and they have been blackmailed, and that was a real significant issue. We had last year vulnerability exploited within the exchange infrastructure, which led to that a larger governmental entity in Germany has been not reachable via mail for a couple of weeks, which had also significant consequences. So what I want to say is that the pandemic had changed a lot, and this will mean that there will be also a lot of new challenges also for the research community out of the changed frameworks, changed infrastructure in that area. If we go to the to the next thesis is that one of the lessons we have learned, as I told, was that we have very fast developments. We have an agile project management. We have a risk-based approach to ensure also quick wins. Again, this is something which is in general a positive thing because it gives us much more speed in a lot of things we want to do, but it also has a risk that security issues will get out of the foreground and get to the back and to the number 2 and others. A thesis I want to talk a little bit more about is the relevance of cybersecurity as a key parameter within geopolitical conflicts. Starting probably showing up that cybersecurity has changed in its importance significantly. So 20 years ago, 25 years ago, cybersecurity, cryptography has been something for a very, very small community. A couple of experts has been addressing these topics, advertising for cybersecurity, but it hasn't been all it has. And if we see, for example, from the World Economic Forum, the global risk map, the current one, and if we ask what are the global risks, and that includes all of the global risks, even climate change and things like that, then we will see that there is a significant part of the global risks directly connected with cybersecurity. That means the economic development is depending more and more on issues which are directly connected to cybersecurity, to cybercrime, to cyber attacks, and to a lot of things in that area. And even more, if we see the last year's short-term risk outlook on cyber of the World Economic Forum, then we will see that within the 5 most relevant short-term risks, including economic confrontations, domestic political polarizations, which we have been seeing the last years, and even destruction of natural ecosystems. One of these 5 is really cybersecurity and the infrastructure connected to that. So cybersecurity is getting a much more, much bigger relevance in the whole world economic system. And now, if we ask ourselves, what are the consequences of this? So what we would take as lessons, what are the things we need to observe within the next years, especially if we will see that more geopolitical conflict will also move to digital geopolitical conflict. And there have been a study I've been participating in 2 years ago. And the example was, what would be the scenario in looking at potential geopolitical conflicts between China and the EU in 2035. And they have been identifying 2 main points that needs to be considered a little bit more in detail. And mainly the points are 2 uncertainties which currently cannot be estimated in a sufficient way. The first one is this, the uncertainty of the sustainability of the decay of digital ecosystems, and that is relevant as by today we cannot say if the upcoming world will see a resilient IT ecosystem, or if we are going to see a vulnerable IT ecosystem. And that has much to do with the role of cybersecurity and cybersecurity technology. So the question would be, will we have in the future cybersecurity technologies that are strong enough to build a resilient IT infrastructure, or will we see also in future an IT infrastructure that is highly vulnerable and that is prone to attacks from cyber criminals and from state and cyber wars? So this is something we need to continue to observe, and at some time to see if we'll get an answer to that. The second point is also important. It is the uncertainty that raises the question whether we will have an integrated IT world or if we will have a fragmented IT world. I'll give you an example for that. Today, we'll see in a lot of areas a very fragmented IT world. If we go, for example, to social media, if we go to, let's say, the messengers, we will see a fragmented world, because we will see in many parts of the Western world messengers like WhatsApp or Facebook, and in the Eastern world we will see completely different ones. That means the two ecosystems are two different directions. And if we want to make a scenario in terms of scenario building, I will see that on the next slide. We can see that there will be 4 potential scenarios, and it's very interesting to see that these scenarios has a very, very major impact also on the way what the conflict lines will be in probably 20 years, 15 or 20 years from now, depending on exactly these questions, depending on the role of integration, fragmentation, and vulnerability and resilience. And so just to give you a couple of, let me see if we can put the next one, yeah. Just to give you a little bit of a feeling what the issues are, to get such an overview and to get such an expectations for the next years. What I want to go a little bit more deeper into is the question about vulnerability versus resilience, because this is something, as I have been seeing it, it's still not resolved by now, and the impact on the economic systems as well as on the conflict lines of the future will be a major one. So, and the main reason for that is that the cybersecurity is, as a technology, still open. In the question whether it is an technology that is helping the attacker, or it is a technology that is helping the defender. What do I mean with that? We have seen in the past many technologies that changed the strategic point significantly. For example, in the military strategy. If we see, for instance, the development of the machine gun by the end of the 19th century, it changed the military strategic situation significantly towards the defender. So it was possible with a couple of defenders having such technology like a machine gun to defend against thousands of attackers with very, very little resources that are used by the defenders. On the other side, if you see a couple of decades later, when the fighters has been developed, things changed dramatically. By then, the attackers has been able, with a couple of very little resources, with a couple of planes, to overcome defending lines which have been defending by thousands of people. And a similar situation we have also in the cybersecurity and the IT area. Currently, it is not clear if we will have at some time a technology that enables us with a little resources of cyber defense resources to defend against a huge amount of attackers. Currently, we are seeing the opposite. We need huge amount of resources to defend against a couple of very smart attackers. And the future development of the cybersecurity technology and whether it will change exactly this strategy will have a lot of impact, as we have been seeing on the world conflict as well as the society, the economic development. So that will be, as fourth thesis, a very important thing. And just to see why I'm not very optimistic on that, this is a slide which more or less didn't change for the last 20 years, that we still have zero-day vulnerabilities as one of the core issues and the core things we need to address and to look at. And just to add, another thing is, you all know the Pegasus issue with the which has been used now for more than 7 years in attacking phones. And the interesting point is that it's still working, and we still haven't found a significant or a general solution in terms of cybersecurity to address these kind of attacks in a way that we can say we have now a class of IT systems that is secure against vulnerabilities of this kind. So, and more or less, probably it is not every time the question of do I have the technology to address that? Sometimes it's also the question, is it a technology that can be rolled out in a way that everyone can use it, and addressing the real issues with that. So let me go to the fifth thesis. I think we heard very interesting things about in the previous talk, so I don't need to get more on it. But I think it is clear that for cybersecurity, artificial intelligence will become a game changer. And I just want to add one thought or one observation that underlines this. Let me just go one more. This is the lack in talents in cybersecurity. We won't get the number of cybersecurity experts we need if we won't be able to automate a significant amount of work which is done today by cybersecurity experts. So we won't have any chance to get with that. These are just a few numbers, having here, for example, around about 2,000 IT security experts as open positions by the German military, just to get a feeling about the scale and the numbers that we are lacking in talents in that areas. So, and at the end, probably, I'm looking also for a couple of discussions or points which are interesting from your side on that. I think one of the important conclusions on that is that we will still have the need also to adapt our legal systems as cybersecurity is getting more and more relevant. And one, in my view, one of the most important things is, for example, is getting towards a clear product liability. So including security and cybersecurity in products should be an integral part of the liability of that products which are provided. And the other things is we need to think also about solutions or ways to handle the law enforcement. We are seeing again in Germany a huge discussion about governmental sites requesting the usage of exploits and vulnerabilities for law enforcement issues. We all know that this is something which is going to undermine the security of the systems in a significant way. However, it's not going to work that we would say we cannot allow from a cybersecurity perspective without offering alternatives how the law enforcement can really be done. And I remember Ahmad working with Birgit Pfitzmann 20 years ago on exactly these kind of cryptographic solutions. For instance, how things can be provided in a way that law enforcement can work, and at the same time, the cybersecurity is preserved. And probably the last point, and that could be very interesting to address the next panel discussion. I believe that all this will lead to at least one thing, that there will be a tremendous amount of chances for startups. There will be a lot of potential for people looking for interesting solutions. There will be a huge amount of money for looking for the right solution to exactly address what I've been talking about. So this is something which I'm pretty sure will give a lot of startups a very, very interesting chances to find the right solutions which could be applied to in a scalable effect. And I think this is something at least positive. So there are a lot of things I'm not very optimistic about, but at least the good thing is that there's a real challenge, and there's a lot of things still to do. So far, a couple of theses from my side, and hopefully there will be some questions we can talk about.
Thanks a lot, Ammar. Very nice talk, because it is connected to thesis, and thesis is something that scientists and particularly startups can start thinking about. So is there any question to Ammar? Yeah, the problem with virtual conferences is that you don't really see people in their faces, so that they can hide and don't ask questions. Okay.
Probably I can add, Ahmad, one thing you have been talking about in the last presentation is there is a gap between the people who know the issues in cybersecurity and the people who are doing the regulations. So I think there's a lot of room, still a lot of room for people like yourself and like others in the cybersecurity domain to participate actively in discussions with the lawmakers, because things change. 10 years ago, let's say the people who are doing cryptography was something, oh, these are nerds and some kind of these kind of people, but things has been changing. So today, a lot of people are really listening to what cybersecurity experts are saying, and they're understanding more and more the languages. You know, things like blockchain led to a situation that people now know that such a kind of very complicated things could have a significant impact on the financial and economic situation. So the people are willing to listen much more. And I think it's all of your chances to get into contact with the people and just doing the same lobbying as a lot of other parts and communities are doing.
I mean, Ammar, I really like this. Thanks a lot for this advice. But from one point of view, since you they took my name and said, yes, we will be happy to help, but two promises should be done. First, lobbyists and interest groups should be taken out. If you want to listen, because currently it's like this. Lobbyists are the first people who get to the politicians and politicians listen to them. We want politicians to come to us, to have direct access. We want them to have a flat hierarchy, then we can help them. If they don't have this flat hierarchy and they just want to listen to lobbyists, and this is what we are experiencing now, it has changed, of course, because there is a generation change, like yourself, like people who have the real background to talk about real stuff. But I am very pessimistic just in our state. I know that what I'm saying is not very, very good for my political establishment, but it is very important that politicians, that we cut the specific organizations and their lobbyists to the politicians, that they really listen first to the scientists who are critical, like myself, and then make their decisions. They don't have to do what we are saying. They just have to listen to us. But in the pandemic and regarding the contact tracing app application, we had a very bad experience with politicians in Germany, and especially with Robert Koch Institute. Sorry, I'm getting politically incorrect, but this is what I'm just telling you. And if you see the report in Frankfurter Allgemeine newspaper from some months ago, you will see that many other colleagues of us were completely left behind. Nobody heard to them. Not only our group that were very active, there were other colleagues in other areas, epidemiologists. Everything in regard to pandemic were ignored because some organizations were preferred. This is lobby politics that is unfortunately killing us from going to solving the right challenges. If you can, another generation of change can cut this, at least partially. I understand lobby business, at least partially. Then we would be happy to help. I don't want money for that, and I know many colleagues of mine who don't want money for that. They just want to have their social contribution. But I agree, things have changed a lot, and we hope for the future it doesn't. I mean, maybe for my lifetime it's not enough, but others, like these young people who are in this call, they can continue, hopefully. Anyway, so I see no questions to you, and I think we are good in time, so we can change to the panel discussion. But for that I need my slides. So let me see if I can share my slides. I hope. So can you see them?
Yes.
So is it full screen or is it half screen?
No, yeah, it's full screen, but it's black side, so it doesn't matter.
Is it visible good enough?
Yes.
Okay, so I asked, I'm happy that all of our respected panelists, whom I'm going to discuss with them and talk with them about the pains and the gains of having a startup, also due to my own experience. And I know that Ammar has a long-term experience with that as well. Also, Harald, Holzer, and the other young people who have made their own decision to set up a startup. But before we go to the topic and the questions that I would like to raise on them, I would like to start with Harald Holzer to introduce himself, and the other panelists after Harald, because Ammar was introduced by myself, but he can also introduce himself at the end. Please, Harald, go on. You are muted.
Yes, I have two buttons to unmute. I did both. Thank you, Ahmad. I'm Harald Holzer, Managing Director of Highest. Highest is the Innovation and Startup Center at TU Darmstadt. I founded or co-founded 5 startups in my life and worked more than 20 years in these startups. At Highest, we are supporting scientists and students to bring their findings, their intellectual property, their ideas into economy. And we have different services supporting students and scientists in the process to become a successful entrepreneur.
Okay, maybe we start with Emmanuel.
Yeah. Hi everyone, Emmanuel Stapf. My name. I am a part of the Sanctuary startup, and we are a spin-off of the Technical University of Darmstadt, and we are mainly working on developing security architectures for embedded and cloud systems.
Sergej.
Hi, thank you. Hi, I'm Sergej. I'm the co-founder and CEO of Code Intelligence. We are a spin-off of the University of Bonn. And what we are trying to do is we want to automate pen tests as much as possible.
Great. Sebastian. Sebastian, you hear us? I think you are muted, or not? So we don't hear you, at least I don't hear you. But I think others don't hear you as well.
Okay, can you hear me now? It's probably
yes.
bad audio quality. Yeah, I guess that's the audio of my laptop. I will try to look what's wrong with my microphone.
Okay, so please.
Hi, I'm Sebastian Stammler from PolyCrypt. I'm a co-founder and CTO, and we are developing blockchain scaling solutions, and we are also a spin-off from the Technical University of Darmstadt.
Okay, Ammar, can you just shortly introduce yourself as well? I know you gave a talk, but.
Yeah, I'm currently the Commissioner for Strategy and Innovation in Saarland, cabinet member, and also CIO, and have been also a track record together with Ahmad building cybersecurity company, and have been then working for a couple of years as a managing director within Rohde & Schwarz as a technology company.
Okay, so one thing that I would like to clarify now is that, as you see, all the people who are representing a startup here, there is no female present. So the reason is because I didn't find anyone. And I had to ask Harald much earlier because I know that Harald knows a lot of them. So this is my apology. We always take care that we have diversity in our meetings, because there are some very exciting female-led startups. But since we were kind of connected to cybersecurity, I couldn't find, I looked for it. So this is that you all should know. It is not something that we didn't look for it, we looked for it. Okay, so let me continue with my questions. The first question is about startup is fun. So when I was looking for pictures of startups, I always saw these happy people. They are jumping around, they all look very sportive, they all look very young. Okay, the young part we can keep. But I mean, it's like they are all personal trainers and they are well dressed. And as you see, they are like very happy. So now I would like to go through all startups and ask our young people, are you so happy? And why didn't you start working for any other company? Established one. Sergej, you start. You work with Google. Why did you work for Google?
Yeah, so we were actually we are a spin-off of the University of Bonn, and at some point when we had this startup idea and we presented it to Google or Facebook, we even got into the discussion whether they would hire us or not. But that would mean that we had to move to the US, because at that time it was all quarter-based. and it was not the feeling that it's kind of your own thing. And we said, okay, if we fail with a startup, we still can continue working for Google, because it's obviously the second best choice after doing something on your own. So we thought, and going back to your question, whether we are happy, I'm happy most of the times, but to be honest, it's a real roller coaster, because we thought we're gonna burn several times. So there were a lot of sleepless nights, but also if things are happening in a good way, it's something that you have this adrenaline and this achievement feeling. And yeah, so I would say roller coaster, but mostly on the highs.
Okay, but you also in the non-pandemic time, you also jump around in the company as these happy young people in the picture. So let me go to Emmanuel and Sebastian, ask them how they look. Sebastian always looks to me very suspicious person. He's always looking like he's not happy with something. Sebastian, tell me, are you as happy or?
I'm certainly sometimes happy and sometimes I'm not. I can also disagree that it's a roller coaster, of course, but I think the reason many people actually got into this, by the way, is my new microphone working now?
Yes.
I found out the bug in my settings, so yeah. I think a real reason is not asking about, do you change your job for happiness, but it's also a lot about purpose. I mean, it may sound cheesy, but really, you really feel that you are in control of what you're doing. So what you're doing is probably something that you feel has some sense in it and has some purpose. And that's really what then makes you happy. But it's like a type 2 happiness. It's not that immediately you're happy and you're jumping around and screaming. But at the end of the day, when you're reflecting about what you're doing, that is really what makes you happy. And that's what makes me happy and what I like, why I like to be in the startup business.
So indeed, I personally remember that Ammar and I, we didn't have really too much happiness at the beginning. It was just adrenaline, as it was mentioned by Sergej. But then when the reality hits and you need finances and you need all these kind of things, that we will come to that and we will ask Harald because he's the big master here. But before that, I changed to Emmanuel, because Emmanuel is always looks very calm to me, like nothing happened bad. So Emmanuel, what is your jumping jack?
If I'm looking at the picture, I'm not sure if we can ever be this happy like this, guys. But in general, I would say for me, and I think I'm speaking for the complete startup, it's just that you can be much more creative and really follow your own plans. I think for everyone that once worked in a really big company with, well, tens or even hundreds of thousand employees. So you just realize that there is just a lot of restriction, a lot of old processes coming from the history of the company that, yeah, really kind of restrict you in your on your daily basis. And I think this is what, like, for many,
you worked for a bigger German company. I don't want to give the name because they didn't give us a car. But what is your so that means you were happy there as well, but this was the reason. So processes, you can change things, you can invent and do it.
You can definitely be happy at such a company. I mean, it was not a bad company, and there are a lot of good big companies in Germany, but it's just different. I mean, yes, you are restricted, and I think you feel that pretty fast. You don't have to work there for 20 years, and you don't have to be, I don't know, climb up the ladder. You realize it very fast that you are restricted. And I think this is one of the main motivations that a lot of people have when they start a startup.
Harald, before I go to the next question and also involve Ammar, what is your experience? Your extremely experience in this area. What is your ups and downs? Why are you doing that? This roller coaster? Yeah.
I worked a lot of years for big companies in Germany, for Vodafone, for Allianz, for 1&1 Internet. And compared to this, founding a startup is a cool thing. It made me really happy. And also the purpose was there because it's your business idea. You want to bring this business idea to market, this business idea to success. And from my experience, it's not only a roller coaster, it's a journey between heaven and hell. And several times I have been to hell, and the next day I was in heaven. It's really extremely, but yes, and also I had nights I wasn't able to sleep. But at the end of the time, it makes sense if you have a good business idea, you have your entrepreneurial skill, and you like that, you can look after people, after employee, which are fitting to you, to your startup. You can build an atmosphere to conquer the world. It's another thing than to work at a company. And 2 startups I built together with Allianz or with KPN. It was a spin-off with a cool idea and yes, a disruptive business model, which we couldn't have built at Allianz or KPN. This wouldn't be impossible. You need, for some business model, especially for these disruptive models, you need a green field. You need another approach than building up such a thing in a big company.
Ammar, you were kind of smiling as all these youngsters were talking about, and Harald was saying about it's a different feeling. What was your feeling? I don't remember that you had time to have feeling.
Yeah, I think I was smiling because what the colleagues has been describing is exactly what was the reason for starting the company, and the reason why we had so much fun is it is purpose. It is purpose. You are doing something where you can define for yourself the purpose. You are not depending on others to define the purpose for yourself. You define the purpose, you have impact, and you still have to struggle, and you still have to deal with all this crazy people around the world, but you have your own team, you can define your own team, and you're going through the ups and downs, the hells and other things that, as Harald was telling, with your team and people you have trust to, and this is fun. This is fun, even in the difficult situations. It is a lot of fun if you have people that are thinking the same way and that have a coherent purpose. They want to also to make it happen.
So I come to the next question, and of course I start with you, Ammar, because I remember that whenever this is about fundraising, as you see on the slide, I hope the slide is visible, are VCs, venture capitalists, helpful? I remember that whenever a venture capitalist, how many times we met with venture capitalists, and you always said, no, these guys want to take over everything. So did your view change?
No, so our company, Ahmad, you know that been able to build without having these. It wasn't be able to be competitive without a huge amount. We needed a bigger partner. But you still can start and reach a significant amount of size without giving too much shares of your idea. Still, however, I believe that there are companies who need a significant amount of funding, and that's the reason why I started in a fund here in Saarland to support the companies for exactly, Ahmad, what you have been saying, to protect a little bit the companies also from being what's called in English übervorteilt, so coming from somebody who's misusing probably the powerful situation an investor might have towards a startup company. So I believe it can help when it provides funding facilities that helps, especially the startups in the very early phase, to get the needed money without giving up too many shares, so that they can keep till they really need to have the big financing round.
Harald, what is your experience with VCs in general? When I talk to companies in US, and I know a number of them, I mean, startups, some of them are very successful and some of them are, let's say, on the verge of going up or growing. What do you think? I mean, it's you can't really say it absolutely, but what is your experience?
VCs could be helpful. There are so many cases, so many startups which need a lot of money in an early stage. You cannot go to Sparkasse or to Volksbank and to ask for money. This wouldn't work. But I think two topics, two main things. It's not only to have a VC, the VC must fit to you. The VC has to understand your business model, has to understand your team, and it's not enough to raise money. You have to raise smart money. The VC must support you, must help you, must be able to give you some networks, some experience concerning, for example, marketing or sales or whatever. And after the VC gives you money, the company has to be the company of the founders, not the company of the VC. This is very, very, very important. And we do a lot of consulting for our startups to find the right VC and to get also in the right direction, not to give too much shares. Otherwise, it's another company. And in an early stage, the company must be the company of the founders. Otherwise, this would not work.
By the way, I must also inform all the participants and also Ammar that Harald Holzer and his team are putting in incredibly lots of time into advising and into directing the companies. I get it from, I mean, I get informed from through Emmanuel and through Sebastian Faust, who is one of the founders of one of these. I mean, I call it Perun, but I know it's wrong name. It's PolyCrypt. I always thought it is polynomial crypto, but it has another meaning. But anyway, Harald is doing a lot, and all these things I don't remember at the time that we started. We didn't have all this guidance and really organized guidance with training, with pitching, and all these kind of things that Harald and his team are doing. They're doing an incredibly good job.
Thank you, Ahmad. We were allowed to do mistakes by our own when we founded our startups. Me too. 20 years ago, there was no consulting for startups. Also, the name startup didn't exist.
No, we are happy to have you, and I think we are very happy with that. So let me go to the next question, which is a general question. Why is it, because Ammar is active in this area, as he said, why is it more difficult to found a startup in Germany, Europe, than in the US? Or is it at all? So I just put this question. What do you think? Because all the successful European companies, and we had a number of them, look at Skype, look at Angry Bird, they were not maybe directly in security, but they were in IT. They all moved, or WhatsApp, they all moved to US. What is the reason? Politics, Americans are more enterprise friendly. What is, when you make policies, are you considering these things, Ammar?
Yeah, absolutely. And I think there are a couple of factors. So one factor is you have a much bigger home market. So in Europe, you have still a lot of national home markets, especially in cybersecurity. You know, cybersecurity is in many fields something you can start selling it to government and so on. And it is completely different if you want to sell it to the French government or the German government or to others. And you see a lot of interesting companies in the US in the security area, which has been funded also by the US government in an early stage. you have a very big market.
We sometimes lose Ammar. I think the connection to Saarland is not so good.
No, I'm northern Italy, so it's not Saarland.
Oh, I'm sorry. Sorry to disturb you at the beach. Okay.
Yeah. No, so I think so. It has also then impact on the investors and on a lot of others, and this is something which is very one significant factor.
Okay, Sergej, what's your point?
Yeah, I actually have 3 points. So one is the customers. So in Germany, if you are a startup and kind of pitch to companies, they have expectations that you are innovative and everything is ready and are kind of impatient there. And in the US, things are kind of, hey, if we achieve this and this, we can make a deal. So it's kind of easier, and they decide faster in the US compared to the Germans, who like have to prove whether to pay 20K per year or not. They have to go through much stricter processes. I think the second point is in sales and marketing. So especially in our area where you have an enterprise product, which is very technical, where you have to explain it, technical people don't want to do sales or marketing, because for them it kind of feels like they are losing it. So you have only a few people, and to be honest, I'm mainly steering sales and marketing in our company, and I didn't want to do it either. So at some point it was fun then, but I remember that everyone in our team didn't want to do that. And
welcome to the club.
Yeah.
So your third point.
And my third point is from the VC perspective. There are a lot of focused VCs in the US, like they are focusing on developer tools or something which is super focused in a niche area. And we don't have that too much here in Europe either. And I think that those 3 points together will make new companies like who are really innovative and do something like enterprisey easier to found in the US.
So let's go to Sebastian. Sebastian, what's your point?
Yeah, I also have to agree to the points that were mentioned before, especially the last point, which I would also call something like infrastructure of investments. So the whole investment infrastructure in Europe is not as mature yet as it is in the US. For example, what you said, they are not like highly specialized VCs or something around that. And another point, which I think is quite important, is the culture. So I think in Germany, there's still a culture that if a startup, not for everyone, obviously all the people here that are doing startups don't have this kind of a mindset, but still there's a lot of mindset that if you are not successful, it's a failure. So instead of saying we are tinkering, we are iterating, we are trying out many, many things, and by trying out something, you never fail if you're not successful. If you're successful, you still learn a lot. You actually learn much more by not being successful than being successful, because if you're successful, it kind of means, yeah, okay, you just followed probably by accident the correct path, but only if you're unsuccessful, you learn a lot. And I think that's actually a quite important difference. Also something so that's my experience dealing with US people, that they have this mindset of tinkering, trying out, being often unsuccessful, failing often, but not really failing. Mm-hmm. Yeah, I think that's another point.
It's a Thomas Edison approach indeed. Before I go to Harald, I would like to ask our participants, because a panel should not be that the only panelists talk to each other. But is there any question and any point of view? You can raise your hand and jump in orally. You don't have to write it in a question and answer. So you have some seconds to react. Otherwise, I continue. Don't be shy. So I don't see any hand raised. Oh, I see Harald.
I never founded a startup in US. With one startup we have been in the US market, But what do you think? What's the role? There's so much more capital, venture capital, risk capital in the US market compared to the German or EU market. Could this be one major point? For example, we had one startup, one big startup now in Darmstadt. This is founded by a US company, by a US venture. And people in Germany are more focused on risk, while the people in US are more focused on opportunities, on chances. Could this be one main point? Everything is right what you said before, but the capital, the risk, to be ready to take risk. This is from my point of view also a very important point. What do you think about that?
I agree. I agree partially, and I agree. I had encounters with a number of venture capitalists in California because I am exploring doing something in California as well, and I had the feeling that they are much more open than venture capitalists that you see here in Europe. And of course, in our area, I will come to security startups. In our area, it is also very difficult to make it clear to people how important cybersecurity is, because many of them they don't understand the background, and when you explain to them, they think, oh, this is maybe a feature that I need at some time in the future, but not now. So why should I invest in it? But Americans in general, they look a bit unconventional, and as Ammar said, for example, in US, many of I see, for example, a colleague or a friend of mine, Per Larson from Immunent, is a startup in Irvine, US, in California, and he's also participating now. And if you talk to him, he will also tell you that DOD, so Defense Department in US and US government, has a lot of projects with startups. So it is kind of economical subsidization, but kind of government helps the small ones a bit. But after that, in US, they are completely brutal. They say, you must continue yourself. Yeah. So in Germany, sometimes, or in Europe, about startups, most of the investors, they just talk about it, but they don't really do it because they want to see cash very fast than many of the US venture capital. This is my subjective view to it. But I mean, Ammar, what do you say? Do you think?
Yeah, so I agree. And I would like to add one thing. So we have in Europe and in Germany, we have regarding the financing of innovation ideas within startups, we have the tools that are provided by the research funding, the EU research funding, Horizon 2020, but also the German BMBF and others. These kind of tools are compensating somehow an early stage funding, which is not available in that way for the US based companies. But there is a major disadvantage for this kind of funding. This funding funds the development of innovative ideas. So if you have a good, cool idea, you can get, let's say, easy money, also exist, and others. But you're not allowed to use this money for marketing issues. That results in a situation that most of our companies, startups in Europe and in Germany, are very technologically oriented, and they invest 90% of their money or 95% in a cool idea, in a technology, in a mock-up, whatever, but they don't have any money to get to the market and market enter everything you're doing with that. In the US, you're getting the money from the investor. So they say, oh, technology should work, go to the market, make marketing, address the market and things like that. And this is something we're still lacking in resources. We're still lacking in As I'm not sure who said this, Emmanuel or Sebastian or Sergej, that we still have not enough people within the startups, and we don't weight the role of marketing the idea in the way it should be. And we think in many ways that having a good idea, having a solution that works is sufficient to get to the market. This is not this is definitely not the case. And if we see a lot of interesting companies in the US, they are technologically far behind the counterparts here in Germany.
Okay, so you are sometimes broken and frozen, Ammar, but let me go to and hit you with some numbers that Lisa Fröhlich did research on to get some numbers about startups. So it's lots of text, and it is some part of it is also in German. It's because we just wanted to know how is the situation in Germany, and then we go to Europe and US. So the number of startups in general in Germany increased significantly, and let's say in 2019, according to what we found, is around 70,000 startups. In the time of Coronas, of course, the number of startups fell highly. Just to give you some impression, as you see in one of these charts. But let me go to some other aspects, like startup activity in Germany. Let's say with more than 500,000 startups, 86,000 fewer people became self-employed, than in 2019. And so these are numbers, and these numbers are coming from, for example, some organization or banks. And as we all know, statistics are only useful when we make it ourselves. So, and this is something that I just put here to give you some numbers. I go further, like startup financing in Germany. As you see in June 2021, it is claimed that we had more than 3 billion euro, or is that a million? I think it's 3.2 billion euros in June that is put in general in new fundings. And then there is this flow into which area. So as we see, fintech, financial companies are growing very fast. In health area, many are growing very fast, and a lot of them are in software, in governance and IT management, and all these kind of areas that are very popular in making new things. So I will jump over these things. I don't want to talk about employment. I come to the US part. So what we see in Germany, you can partially compare it to other EU countries. I'm talking about EU. Now I put a lot of information here on this slide. Where we see, for example, that it's one of this is from Forbes website and Forbes studies on startups. So for example, the core regions is of course Silicon Valley and New York City or Boston, because top universities are there. People can get the graduates from there. Then 21,000 startups which compete or rely on cybersecurity. So 21,000 startups in cybersecurity or related to cybersecurity. This is a huge number of startups. And then according to this report, 1,653 of them received seed funding. And the investment in security and privacy in US was around $10 billion, which is a good amount, because we saw that during the pandemic, as Ammar said, everywhere the meaning of cybersecurity, the value of cybersecurity has increased a lot. So after all these numbers that I put here and very fast went through them because they are not important, can we talk about, is there any useful strategy to establish a startup culture? If we see that in America, okay, it's a much bigger country than Germany, but if you put Europe together and EU, let's say we put EU together, then it is comparable. Is there any useful strategy from the government point of view, Ammar, to establish a startup culture? Do we need a startup culture at all? Oh, there is a question.
Yeah, so
I will come back to you, Gerd. Yeah, okay.
To give a quick answer. So first of all, the last slide you just presented is what I sent in my presentation. There are so many chances for cybersecurity. Never has been so many chances for cybersecurity companies, but also in Europe and in Germany. So if you have a cool idea, if you can communicate your business, you will be able to get significant amounts of money and to address the markets. You still need to be successful, but at least regarding the money investments, you will have the best chances to get that. And regarding the question of the startup culture, I don't think that government will be able to set up a startup culture. This is something which depends on so many pillars within the society. I think very smart guys like Harald at the people who are probably afraid that getting a startup is not a rocket science. It is hardworking, but it has also a lot of fun. I think this is something where we can put much more efforts in. And I think the best thing is to establish a startup, to get more people starting companies, are role models. All you guys here in the discussion and other parts who are talking and saying, okay, it's cool, we have good times, we have bad times, but this is a real thing I can advise also to others. I think these kind of role models, they get young students or people starting an own business and getting into this
Let me, before we go further, we go to Gerd Leuchs. He raised his hand. Professor Leuchs, please. Are you there? He's not there anymore. I thought he has a question. Leuchs?
Hello, can you hear me? Hello, hello?
Yes, we hear you.
Now you hear me, okay. I switched, maybe I closed my laptop. Maybe this is why, but okay.
Yes.
So I wanted to share my view on this with you. So first of all, I think, but this is from some 10 years ago, but maybe these things don't change so quickly. My impression always was in the US, if you start a company and then you have to close it again, you are in high demand because people think, oh, this guy has experience. And in Germany, if you fail, the message goes around, well, he has not been successful. So I think it's something which is a little bit deep inside people, in the psychology. And then at some point I had this dreadful thought that, I mean, only in the 19th century, there were millions of people from Germany immigrated to the United States. So all the risk-oriented people we lost. It was even such that I think at one point in Congress in the early 19th century, by one vote, English became the language of the United States. It was one vote, otherwise it would have been German. So there was quite a number of German people immigrating, and the people who were not so risk-oriented, they stayed behind, and we are the descendants. So maybe we should not be surprised.
So maybe it is indeed a cultural aspects of it. So if you think, Ammar, that setting up a culture is startup culture is not something that governments can support, or at least they can encourage it. They do. But I have most of the time the feeling in Germany that government is talking too much. Harald, please go on.
To your question, startup culture. Yes, we need a startup culture. And we at Darmstadt, a technical university, are like our startups. We offered good service. We made a lot of good things. but we didn't talk about that. Nobody knows us. Not our internal customer like students or scientists, nor the politics or the economy. We have to change these things. We have to set up a communication in a professional kind of way. This is what we are planning, and we started now. It's quite similar to our startups, and we need the culture in the economy. We need it at our organization. I think we need it everywhere, and we need also success stories of our startups and why is it cool. There are different things, and I agree. It's not. It could not be done by politics. It has to be done by us.
Sergej.
Yeah, I just wanted to disagree with one thing. I don't think that people will think that if someone failed a startup is actually a bad thing. I just think that we, from the perspective of oneself, it might feel like it seems like a failure, but from outside, after you kind of closed your company and you apply for new companies, I don't think that even in Germany, anyone will see it as a negative point that someone started a company and failed 2 or 3 years after that. It's just this fear that someone would think it, but I don't think it's really the case.
Maybe I am a bit old, but I absolutely agree with Gerd because because I think in Germany, if you do it, if you're successful, the word goes around, and they say, look, the poor guy, he could not make it. Yeah, so let's don't cross the way with him. Anyway, so Harald, did you want to say something?
Yes, I want to add, I think 5 years ago we had the situation, if anybody wasn't successful with his startup, it was not good for him and for his career. Now I think it changed, as Sergej mentioned.
I hope
yeah.
so.
Yeah.
Let us go to another question that maybe our youngsters here can contribute to. What are, and of course, experienced people like Harald, what are the common startup mistakes? So if I looked to several white papers looking what they say, that I would say, hey, they are right. So there is also a picture I found, which is nice, like top 10 startup mistakes, like building something nobody wants. Okay, so I think we all ask ourselves before we start a startup, or hiring poorly, or ignoring social media. I will come to that a bit later, or failure to execute sales and marketing. That's what Ammar was saying, and not making sure you have enough money. This is This is also make us startups dependent on venture capitalists. So, what is, in your experience, the typical problems of startups, let's say in Germany or in Europe, or what was according to your experience? Let's start with Ammar.
So was it me,
yes.
Ahmad? Yeah, so I think the graph is exactly points on the point. Building up once, I think this is it. So because we are so quick in building things, we think we have the greatest solution, and probably it is a good, but sometimes we then start searching for the problem we are losing, we are solving, which is a real issue. And that is the reason why
I think you need a startup.
We made something we call reverse pitch. So can you hear me, or it's still difficult?
Yes, now I hear you. You need a startup in Italy.
Okay. Yeah, we need more. So so what we did is a reverse startup. So not the startup is pitching, the company or the institution who has a problem is pitching. They're pitching the problem. An industry company, for example, is pitching the problem and says, we are looking for somebody who's presenting for us a solution. And then there are a lot of listening to that and say, okay, we think we can solve your problem and provide a solution. Then you have directly a business case, you have a market. And
this is actually a great idea. I like it. But is it possible to do it in Germany? Would Siemens come to you and say, we have a problem? You know, Siemens always say, we don't have a problem. You have a problem.
Yeah, because they are realizing that they are missing innovation capabilities. And we did it, for example, with ZF, Friedrichshafen. You know, this is a very, very big company. And it is a very German style company. But they're still accepted that, and they're moving towards that, and the university is following this as well. So we're experiencing, and I think this is something. This is another point. We should do much more experiments. We should have the. We should just try things where we are not sure if they are going to be successful or not. But sometimes it makes sense just to try the things, and then to evaluate and to decide whether to continue or
not. Okay, so Sergej, you have a question or comment?
Yeah, it would be more the comment. I think that the top 10 mistakes on a macro level, it's quite good. So I would agree with everything there. But focusing more on what is special for Europe, I think that building something nobody wants is much in the, so it's the top one, I think in the largest one with 36% over there. So is actually like maybe a European problem, because when we founded the company, we got like advisors from the exist board and so on, and everyone was saying, yeah, you need to develop the product and then you try to sell it to everyone. But actually, if I would restart the company, I would start with sales and marketing and first seeing what kind of messaging is going better. And after that, I would start with little prototypes for specific companies and completely like almost for free, because when we switched to that we didn't charge for POCs like it was advised, when we stopped building the product first, but solving the challenge and then improving the product, things accelerated much more in our company. So we should go like reverse. First, sending the message out, build a fake product site and see how many people sign up first with the way, and then improve your messaging first. And after that, only start with the product. But for this, you need a lot of money to do the traveling, to talk to people. You need money for the Twitter ads or whatever experiments and so on. But yeah, and this would avoid this building something nobody wants, which is kind of the European problem. And we made the same mistake. I'm not saying that I didn't make it. We did the same mistake.
Okay, Emmanuel, you were silent. Say something.
Yeah, I just wanted to add to what Sergej said, because I also completely agree with that. And I think it fits nicely to what Ammar said before, because I think it's also really sometimes a problem of the funding program, because this is a bit also what we are experiencing. So I think all of the startups that are in the group now were funded at some point by Startup Secure, and this is also the program where we are funded. And there, at least, they have the idea that there is a development phase and a selling marketing phase, but it's also much too strict. And if you are developing your product for 1.5 years, and then in 1.5 years you start, talking to customers, I would say that's way too late. And you need to start way earlier. And in the program is a bit too static in this way. So you are actually not even able to use your money for that in the first phase. So I think the problem is also, at least for our experience, it's also a bit caused by how the funding programs are structured.
Absolutely agree. I think this is where the politics can change. in this shows exactly the uninformed part of their politics, because you want to support startups, you want to give them funding that is really good, that is very nice, but you, on the other hand, you restrict them to so many bureaucratic stuff, like you cannot hire this, you must be a research assistant, you cannot do that, you cannot do this. And then after 1.5 years, you may have developed something, but you have not sold it. And the whole money and the whole funding is, so to say, it was a nice experience, but it's gone. So, Sebastian, you want to say something?
Yeah, I mean, it has now all been said basically that it's just a big problem of of building something, especially when you're in love with your technology, because especially in cybersecurity, people actually absolutely love what they're doing, so they're getting into it way too deep, doing it for months on end, and never checking if it's actually needed. That's the one point. And I think another point, of course, is that it's very important to understand that, especially in a small team, in a startup, it's a people business. So the team is so super important. You cannot only say, I have this idea and I'm just hiring someone because he has good credentials or whatever. It's even more important that you get along with your team very well. That it's so super important, because only if you support each other and if you like each other, only then you can stay motivated. And it's much better to have a team of 5 very good developers that are all getting along with each other and are motivated than having, I don't know, like some super special unicorn, but you're not really getting along with that person. So I think focusing on the team and on the people is also very important.
Please go on.
One thing to add, you are completely right, and I go in the direction of Sebastian. One common fail is having not the right people in the team, or having not a good team, and this is the founder team, also the advisors and the investors, and this is for me one big issue and one common problem of startups which failed.
Okay, so let's go to the next my next question. So I put here avoid startup failures. I think we already discussed some of it. If there is a point that you want to mention, or anyone from the Sebastian, do you want to say something? If not, please unraise your hand. If there is any question from the question to this discussion from audience, please raise your hand, and I'm happy to give you the microphone. Otherwise, let's go to the next question that we discussed a bit, but is it especially difficult to establish a startup in the security domain? Is that what we think, or is it real? Who wants to go first? Harald, what do you think?
I think yes. To be honest, I think yes.
A clear answer. Great. So, Ammar, what do you think?
Trust and confidence in the security market are even more important than in other industries or other markets. And also reference customers, reference projects, especially in Germany and Europe. And the startup doesn't have this reference project and reference customers. And if I look,
sorry.
And if we look to a company, a customer, if there would be any issue with a startup in security, I'm sure the CTO or CIO would have an appointment with the CEO in the next hour and the next day, and this could be one thing. And the other thing, there are a lot of good jobs in the IT security or in the cybersecurity area, so that you have the unsecure startup as one option and the secure big company which wants you to hire. This might be the main, from my point of view, the main issues.
Emmanuel, what do you say?
So since this is the first startup I'm building, I can, of course, not fully answer the question if it's much easier in other areas. But I would also think that it's maybe in some cases a bit more difficult I mean, if the companies are already security aware, then I would say it's like in other areas, you compete with other companies, and yeah, probably when you have a good solution, then you can sell your product. But I think in the security case, you also have the problem that a lot of companies are still not really security aware, or they are at least security aware, but still don't want to spend money on that. So I think then it gets really difficult if you still, again, also you at least, well, in the first place have to convince them that, well, actually they need security solutions. And I think that makes it even more difficult. So I think most of the time you need some additional selling arguments besides security. So I don't know, you can save costs somewhere, hardware maybe, or at some other place you can save some costs. So I think it's only with the security argument, it's still very difficult to sell products.
I agree. This is also my own experience, although as Harald said, security is becoming so important that people, if you talk to big companies, they want it, small companies, they want it, government wants it. So but still, there is no motivation for, financial investors to say, oh, we need to support good ideas in security. Sergej.
Yeah, I think from our experience, a lot of companies want something where they take over responsibility. So for the products where you kind of get a certificate or can say, I have done something against it, and which things are easy to implement, those for those products, it's kind of easier to implement a startup in the security sector. But some startups are focusing on actually improving some software, or they require some more knowledge. And I think that those companies have a more difficult situation, because in IT security, it's kind of very complex buying center. So if you are improving software security, who's responsible for software security? Is this developers? Some companies have an extra security team. Other companies have external teams which are improving security. So in that case, but the same for taking care of the company's network. You have like either own operations or some other administrators are responsible for that. And so it's more complicated in that way. And I think, so for some startups, it's easier, and for some products, it's harder to get in.
Yeah. So indeed, a related aspects of it, I mentioned at the opening of the conference yesterday that Germany, with having several big centers for security, like Karlsruhe, Bochum, Saarbrücken. Oh, I see that Saarbrücken has a typo, and Darmstadt. And in total, 100 millions of euro has been invested into cybersecurity and privacy aspects. There are many top researchers in this area. The market is even empty that have already been hired, and they are working on really problems. And in terms of top publications at tier 1 conferences worldwide, I made a kind of homework and looked into it in the last 3-4 years. Germany, when you put all these the outcome of all these institutions together, is number 2 after US in terms of top publications and partially in terms of impact. But the real impact, it's still coming from US because of the good or let's say very active public relation and advertisement machinery, and of course elite universities. If something comes from Berkeley, comes out from Berkeley, and we have already invented that 5 years or 10 years ago, sometimes it is completely ignored because it is Berkeley on it. And we know that. And we like that, because I like how Americans do it. They know how to do it. They just don't, to be honest and not politically correct, they don't care. It's Berkeley, it's MIT. Everybody knows them. And why, if I put, hey, in embedded systems, we have done this work 10 years ago, please look at it. But no, it is not new because it is coming from those universities. But they do it actually very nicely without insulting anyone. Yeah, they just ignore them. So having this, what would be the what is actually the strategy to convert this amazing research that has been done in all these institutions, which is very competitive in worldwide so to say stand. How do we convert these results into more startups? Not that our best people go to Google and Facebook and you name it. Yeah, Sebastian, Emmanuel. Sorry, I just mixed you up.
No problem. Well, I think actually that we are not on a bad track in Germany. I think with the digital hub, cybersecurity, and also the startup secure incubators and so on, I think actually there is a lot of going on. I mean, you can see that from the startups here, which are funded. So I would again say that we maybe don't need much more programs, but fit them better to the needs of a startup. So I would repeat my point from earlier, maybe.
Okay. Ammar, do you want to say something? Because you are in Saarbrücken and they are also producing something.
Yeah.
But what is the impact? What is the impact? How can we make this impact bigger as Americans are doing? Are you frozen or you are just?
I think one thing could be to rent. Yeah, can you hear me?
Yes.
Now, okay. So I think what you can do is you can work toward a brand, a joint brand. So as you were telling, if somebody says this is a startup where the people are coming from Stanford or Berkeley or MIT or whatever, so they have good chances to start. And I think by making the successful starts from Bochum, from Darmstadt, from Saarbrücken, from Karlsruhe, and to show that this is some area where a lot of interesting startups are coming. And the other point is the critical mass. And that's the reason why we're building in Saarbrücken an innovation campus with 100,000 square meters, only dedicated for cybersecurity. And this is something where we want to really put all these resources together. It's not only for startups, it's for startups and for industrial labs, for Symantec, for CDEP, for the BSI here. So having all the relevant people together so that they can exchange and they can build some critical mass, building really large companies.
Yeah, I think this is a similar situation as we have in Frankfurt and area with fintech. But I also think that we have the capacity in our state and also in connection to other European countries to create a real strong critical mass. So anybody else wants to express himself to this aspect? If not, we go to back to the startup pop culture. And this is my favorite example of politics, wrong politics, of corrupt politics, of greed, of hypes, of rise, and of fall. Wirecard is a financial company that was praised as as it was founded. It just does financial transactions. And when you are in financial area, you can read about Wirecard. It's like a Hollywood movie, but in real. I show you an American version of it as well. So many politicians supported this. So assume that all these three startups in this panel, would be supported by, let's say, some high-profile politicians, like the German chancellor or any other politician. I don't want to say names. Yeah. And all of a sudden, these guys from Wirecard were sitting in the delegations, high-profile delegations everywhere in this world. They got so much support. They were so much praised for how good and how genius they are in what they are doing. But nobody knew what they actually are doing. So Let me go to the next slide. This is one of the CEOs from Wirecard, who had very good relation, according to himself, not only to politicians, but also to Secret Service. And this is how he looks like now. This is a warrant by police, international Interpol. They are looking for him because several billions of euro has been vanished. But these guys got a lot of support from politics, a lot of support from media. And I am asking now our startup youngsters, before I go to Ammar and Harald, this is the role that politics have played, at least in this case. There are many other cases. I just put these two cases because it was really interesting. So what do you think? Is it worth it to be supported by politics and sell hoax and become one of the most successful startups? Or so, because we talked about role of the politics. So politics plays a role. Which of you startups have been in contact with some, so to say, politicians, local or at the federal stage? And what is your view to the support that you can get from politics? Who wants to start? Harald, what do you say?
I would prefer to have a network in economy, customers, network, project partners. And yes, for sure, it may be a good thing to have support from politics. I would prefer to go the other way around.
Okay. I know it's a very provocative.
Yeah.
I like to provoke a panel.
If you want to sell masks, it could be an advantage, something like that, or have some products in the other security area.
Ammar, what do you say? Because why I am asking this, because there are a number of startups. When you are in the scene and ask people, they are looking really for lobbyists who have good connection to the government. And that is what happened with Wirecard as well. It is not a problem that politics supports own industry. It is a problem, how do they evaluate what these companies who are under extreme pressure to have success, that they are also telling them the truth, because governments cannot go and look into your books. So on the one side, we want this. On the other side, it would be very dangerous, because startups start to talk more to lobbyists to become successful rather than doing the job. I know it's a question.
Yeah, I think so. First of all, I'm not sure if the Wirecard example is a good one, because this is a heavily criminal situation. So I think it has been really heavily criminal, and there have been a lot of mistakes being done, a lot of mistakes looking at the controlling facilities and so on. And we see the reason why politics supported Wirecard so massively is that we had the impression, or the politics had the impression, this is the only innovative financial company we have, and therefore everybody goes there. That's
the point.
Yeah, that's a bad situation, and I think politics must learn that even if we look at new things, we need to evaluate them and not just to jump at somebody who looks nice and somebody who say, oh, I have something with artificial intelligence. Oh, very good. So everybody goes out there. Thinking about using the brain is something which is sometimes also in the politics helpful. The other point is the question whether it makes sense to put efforts in context to politics, lobbying, and so. I think it's more important to address the market. I think addressing politics is nice to have, because you can do some PR, which is much cheaper than marketing. but don't waste too much time. So my advice to most of the companies, to startups, is get a little bit involved. If you want to have a PR, if you want to be on a on whatever RSA conference and make a photo with whatever, some politician, you can make PR with it. It's cheap because you don't need to pay the politician, he does it for free. And but put your efforts into the market, into the companies, into your customers. At the end, the only who gives you the success is your customer, who says, I'm willing to buy your product. Forget the politics on that.
Okay, Sergej, Sebastian, you wanted to say something. At least your hand was raised.
Yeah, I think that this business with politics gets at a later stage. I think most of the startups don't even have the power to kind of get involved into politics. But if we talk about some companies after the IPO, they get another pressure because it will get harder and harder to grow, but the expectation is still to grow. And then specific sectors are kind of similar to in the academia, you have publish or perish. You have the same thing here. You still need to grow, and then you start to be involved with the politics. But I would say for most startups, politics isn't even a topic where they think about it. I mean, obviously we are lobbying, and there are some ISO standards, and if you want to do whatever, but it's not politics yet. But if we would be a company after an IPO, maybe politics would become more important. And I think it's a natural way. The bigger the company is, the more you have ties to politics.
Okay, so let me go to another example that is also very extreme. I took this extreme ones, that's true, just to have a provocation in our panel and see what you say. So this is Theranos CEO, Elizabeth Holmes, who is not going to a trial. I don't think that they will put her in prison, because in US, if you are from certain privileged places, you don't go to prison. I don't think so. But she was praised by Forbes magazine and by Fortune and by all of them for the next Steve Jobs, because she was also obsessed by being Steve Jobs. And today, Theranos is indeed, and it's called a 9 billion scam, because $9 billion was the value of this company, which was in Silicon Valley, was valued this. So the hype of Silicon Valley. So what I'm just trying to say is that the idea of having one, let's say, one drop of blood and put it in a device, and the device gives you in 1 hour all the blood tests that you do with Siemens machines, and you need 2 or 3 days in a lab to come up with the results. This idea was, of course, fascinating, and this was in US. They were fascinated, but it was very easy to fascinate venture capitalists, but also politicians who were advisory board. Many former US top politicians were the advisory board of this health company, but none of them had any background on health. So what I'm just trying to say is that it is possible to become successful. It is possible to get lots of promotion with a good idea. But there are, as Ammar said, is that when we start to think to hype something without looking critically into the, let's say, what is actually the background of this company, what they are doing, what they are not showing us. And I think this is very important, especially in US. If you have to have, if you want to have success, this obsession with success can also go wrong. But I myself feel it as well, that if you have a startup, you have this enthusiasm that you need to show that you can do something, and maybe others don't believe you. This is why I put these 2 cases that are really extreme. Now, the same Forbes magazine has published the best 20 best cybersecurity startups from 2020. And if somebody reads this, all the VCs and investors, they will get, oh wow, Forbes wrote that, because people think that what they read in Forbes has any substance. But if you're not critical and you are in this community, so do we need this kind of culture so that also our cybersecurity companies to get pushed by the media and by a strategy behind it, so that investors from all over the world at least get into this area and say, hey, they have very nice innovative ideas, even if, let's say, these ideas cannot be realized in a short term. What do you think? Do we need, this is also part of this culture?
Ahmad, can I say something?
Yes, please, go on.
Yeah, so I think this is a very good idea, and this is exactly what I did the past 3 years. I made an format where we just visit. So one of the big things is, or big issues is, that it's sometimes difficult for startups to get high-ranked dates with companies, with big companies. So what I did is that I asked my boss, my prime minister, to join us for visiting the CEO of Siemens, or the CEO of Ford, or the CEO of Mercedes or BMW. You know, if somebody like a prime minister asks, I want to have a meeting with you, he usually don't say no. And the thing is that we took something like 10 startups from Saarland. So the things work like this. We made an appointment. We called the CEO of Siemens, Joe Kesa, at that time, and say, oh, we wanted to visit you. We have a couple of things to discuss. He said, oh, okay. So we may do it in November. Then we said, there will be also some 10 startups accompanying us. They wanted also to present some of their ideas. And he usually don't say no. And they say, okay, then I need to get my people. Then he gets all the relevant people involved. And then you have a situation where the CEO of Siemens and 20 of his managers are sitting and listening and forced to listen to these startups. And this is something what politics can do, just to open doors and to help getting attraction to startups who have probably good ideas, but nobody's looking at them.
Exactly. So I think this is where we, okay, Emmanuel, you go on.
Are you only doing that for Saarland startups or in general for German startups?
So, Emmanuel, you can join Saarland at any time you want. So this is not a problem. And I think it's a good idea. So I can.
Yeah, I agree. The idea sounds good. Yeah.
The idea sounds good, but we need you here. We don't need you in Saarland. I mean, who goes to Saarland? I
told already Christina, my colleague from Hessen, that she should make separate similar program, and I think she liked the idea, and probably she will do something in Hessen.
Yes, as well. Please connect her to Harald Holzer.
I wrote it down. We will also ask Jens.
That would be great, that they listen to us, to real people, and not to the lobbyists of certain organizations. Ammar, you know what I'm saying. So, okay, what Emmanuel, you are finished with your thing. So I think that we are approaching the end of the panel as far as I see. There
are 4 more questions in the Q&A window.
But these are not questions, they are comments. Okay, I think some of them were answered, like, okay, I can go through them. IT security is like insurance. It is necessary for the business, but usually not the business. I don't agree with this. Anybody thinks that IT security is not insurance anymore? It's a technology that should be an integral part of anything. But I understand this. I looked at these questions, and then that the job of the politics to support the German industry, that is okay. In hindsight, I do not see any reason why Wirecard should not have been supported. We also don't see why not, but as Ammar said, it was the only one was considered as really innovative in financial area. That's the problem when you are just focusing on one company. The root cause may rather be that politics aims to promote any business in Germany while turning a blind eye. How can we encourage politics to prioritize ethics over business? Okay, we didn't answer to this question because that wasn't a question of a startup. Politics and ethics. I could say, Ammar, I give it to you, but I don't want to put you on a spot because ethics and politics and business, this is a very complicated situation. Ammar, do you want to answer this question?
I'm not sure that ethics can be prioritized about business because the business is ruling, that's it. But ethics need to be determined in the frameworks around. So if we as a society believe that there are dedicated ethics rules that need to be complied to, then we need to put that as politics. And then we need to be very, very careful that we don't raise disadvantages for our companies, for example, in Germany or Europe. So if we put regulations on that, we need to keep that the regulations also affect foreign companies as well, and not only the startups or the companies here in Europe.
Exactly. So, and I agree. So, and then there's another comment about other German scams. We didn't really want to talk about German scams. We wanted to have two IT examples that were in US and two extreme one, just to provocate a bit. Now, Tien Nguyen is asking, as you all agree, forming a team is very important. However, I see that most IT startups start with co-founders who have a purely technical background. Do we need to find co-founder who have business background? Ammar, what do you say? Or Sergej, what do you say?
I can answer that question. I don't think so that it will work because actually, if you apply for the big exist fund, you have to bring someone on board who has a business background. But the problem there is, let's say, the technical people usually don't have a business background, and then they hire someone who's supposed to have that. But this person doesn't have any background in the tech at all, and usually it's not compatible. And I can't tell you the source, but as far as I know, those exist business partners who are joining there are often not part of the company anymore. And so what we learned from one of our sales coaches, so someone from the technical people needs to become responsible for sales and marketing and say, now I'm diving into that area, and this usually works better. And I don't think you can bring someone from outside and this person will learn all the tech behind the big deep tech faster. So it's the other way around. The technical person has to become a business person.
Sebastian, you wanted to say something?
Yeah, I also agree that it's, I think, very hard, if not impossible, to just bring someone from the outside after like 1 or 2 years. I mean, maybe you can do something like when you're a little bit bigger, you can find a like professional CEO, so to speak, very experienced ones. But when you're still small, you don't have so much to offer, right? So it's very important that everybody has to be so motivated that it has to be within the team. And if you find someone within the team, that's the best situation that you can have, that you have a technical person, maybe someone who doesn't want to be fully on the techniques and then goes into more the business and marketing side. But yeah, I think it has to be on the core team, someone doing that.
So Ammar, do you want to say something? Otherwise, we are going to close. And the closing is usually in every panel, every panelist says something amazing, smart. I will start with Emmanuel because he's smiling. say something smart about
Not,
your future. Your future.
not really sure what smart thing I can say. What I take away from the panel is really some nice ideas of Ammar, I think, and I hope that maybe also in our area we can maybe start such a rounds to get more into contact also with industry early on. That's what I take away.
Sergej?
Being smart when pressing a button.
You are making a startup.
So I think you're good at being smart, being funny when pressing a button. But I think that I learned a lot today from the perspective, and I kind of felt that there was an agreement with some of my views, because the others told basically I didn't even have to comment everything, because others had similar views that we have to change kind of how the programs are designed. So because we have programs which are kind of replacing the VC power of the US, and those programs have some little issues. So in our case, we had a huge discussion because we had more than 20K traveling costs, and you need that to talk to all the customers. And I think that Emmanuel and Sebastian mentioned some other examples where it was a bureaucratic process, but in the beginning of a startup, you have to learn a lot. And maybe if we kind of change the programs that this learning is part of founding a company, we get the same success as the Americans.
Sebastian, your turn.
First of all, I want to say that I really have the impression that the culture in Germany and in Europe as a whole is changing for the better. So, I mean, just hearing all the people here listening to it, and now we're growing up and being in positions where we also then give the way and change how it works. So I really, I'm optimistic about how it's developing in Europe. But looking at this particular example of those programs, yes, I think they should really learn to listen to startups and really get into contact with them. So if politics, and especially like the BMBF or whoever wants to support this, which is awesome if they do, they really should not talk to each other, right? I mean, they're talking to people who don't really know what's going on. So they should ask us, and not only write an email, but really get into contact with Sergej, with me, because otherwise, and then really ask, okay, what were the real big problems? How can we change the programs? And that'd be great if that happened.
Harald.
Yes, culture is changing. I like this. And what we are doing in cybersecurity and IT security with our startups is very good. And we have to communicate in another way. It must be relevant, more relevant for society and politics. And the format Ammar talked about with the CEO of big companies, with the politics. I think we will do this in a similar way in Hesche, and I would like to invite you. I speak today with to Jens Schneider. He has to arrange this with our politics.
Absolutely, and I think we should also kind of recruit Ammar, give him much more money. I mean, he doesn't need it, but okay, and bring him here to work with us.
Thanks, Ammar, for this this idea.
Your last sentence, Ammar.
So first of all, just to give you, I'm really congratulating you to what you have been putting on the table within the last year. So it's really good. And Ahmad, also to you, I think one major factor we didn't talk about is having professors that encourage students to go for startups. This is not something which is usual. We have a lot of professors seeing, just looking at excellence, scientific excellence, and telling the students to go for a professorship rather than starting a company. So that's something really important. And having people like Harald who helps, who knows what's the things. And I'm very optimistic seeing all these young guys getting with their ideas around. And there are a lot of more startups in Germany in the cybersecurity business. So I'm really very optimistic that we will be able also, if we sell this on a marketing level, that we will have also the brand name in Germany, that we have the best cybersecurity startups, and that we are really towards solving the cybersecurity issue. And so I'm really very optimistic. And so thank you very much for having this discussion with all of you here. I think, at least for me, I have a lot of new insights. And so thanks a lot. It was a cool time.
So thanks a lot to all of you, and also to those who, specifically to our panelists.